Okay, we are live. Whoops. Yeah, it's probably fine. Puffer's fine. So, we've got some cool stuff to look at. Talk to work on, several things. Let's see. I want to start, though, today. We're going to look at these experiments in a second. I want to start with one thing real quick on Twitter, which is I have a collaborator who's back from... Where is it? I just saw this notification. Where is it? Oh, there it is. Oops. Let me make one post here, and then we'll go through experiments. Definitely go follow Kyung. He hasn't really used Twitter much up until now, but he's getting into the AI game, which unfortunately means mandatory Twitter. So let's get him started on that. There we go. Got it. We're set. Okay. We are ready to get started here. So, we have some cool results. Some very cool results. I got up this morning really early, and I made some changes as well. So I don't know what's up with this Pong sweep. We're going to look into this a little bit today, because this is really weird. So we'll have to figure this out. Let's start with the one that actually looks good, which is the new sweep here. Jeez. I always jump on stream right after I get out of the shower, and it's the result. Anyways, here we have these 59 runs and then these 21 runs, I believe. Okay, I think I'm good. So we have, this is what happened yesterday with the runs. So what on earth? Welcome, YouTube folks. I am not dying. We have some cool experiments to look at. Jeez. So, I'm not even sick either. This is bizarre. So, we have some cool experiments to look at here. From yesterday, I ran this hyperparameter sweep on the MOBA, and the metric optimized for was total number of towers taken. So you can see it starts running very small experiments, right? And then over time, it gradually runs longer and longer experiments. But isn't it weird that these are like capping out? Like the total number of towers taken is capping out? Because this is the total number of towers taken over the whole course of training. This should be able to be like linear. And then better runs would give you a steeper line, maybe. So I went and I looked at the code, and it looks like the towers were not getting reset correctly between games. So you could really only take the towers once. There was a bug, right? And this is what the sweep curve looked like, right? We get all these hyperparams. And then here's the new one, which I just started this morning, but it already has some good runs on it, right? Here's towers taken. And this is exactly what we expect, right? We have straight lines with higher slope being better. And we can look at a couple of these, right? The rewards are different. The rewards aren't super meaningful on their own. Does the reward go up over time? Hard to say. But regardless, we've got level means. You can see all these these waves are when it's resetting games. You've got the XP reward where you can see it's like getting more XP over games. Again, it's like cyclical because different games. But you can see that they're getting up to high levels, right? So they're actually like fighting and farming and doing all that stuff. And they're taking towers. So not even sick. It's ridiculous. I start my days out with a bunch of exercise, and then I end up taking too long of a shower, and I just get all like fogged up. Okay, so we can see that this sweep is working out nicely, right? And we will probably get some reasonable hyperparams from this. You can see we get reward weights on the left here. Train batch size is 1,000,000. That's the 1, 2, 3, 4, fifth column. BPT horizon of 1 is very weird. You know, you never know though. Clip coefficient of 0.25 is reasonable. Entropy coefficient of 6e minus 3 is very reasonable. Lambda of 0.97 and gamma of 0.995 is pretty reasonable. I don't know why it would have the BPT horizon be 1 though. And then we've got the learning rate is 70 minus 3. That is very, very high. Apparently it works though. Probably because the mini batches are so big. Max gradient magnitude's like 0.45. That's reasonable. 32K mini batch. Total time steps 1.4 something billion. 2 update epochs per data sample. Is that right? Wait. No, 1 update epoch. I'm reading that wrong. Good. It should be 1 update epoch. That's what I would expect to be the best. And then what else do we have? Value function clip. Very, very low value function clip is kind of weird. And a very low value function coefficient. So a couple weird parameters, but mostly what we would expect. And I think we can just let this thing keep running for a bit. This one's pretty well set. I'm interested to see where this one goes. It should just keep running longer and longer things, but I also want to see what the trade-off is, because it should allocate some of the processing power to trying to find steeper lines instead of just running it for longer. So this is a pretty good test, right? Because this is kind of how RL works, right? Is like if you have a good environment, it'll keep getting better over time regardless, right? As for any reasonable set of hyperparams, but it'll be steeper for good sets. So I think this is pretty nice overall. Let's look at the Pong sweep, because this one I need to look at and see what happened. Where is it? 15, 19. Okay, this one has a whole bunch of runs. So what's going on here? Oh, wait, it does work. Why did I think it didn't work? Like when I refreshed it before, it looked weird. Okay. So this does work, but it has a very weird graph shape. And I'd like to figure out what has happened with this, like why it looks this way. This is going to give us a very good, some good insights on carbs. And we're actually going to let this one keep running because I want to see if it can solve this any faster than it's currently solving it. So that's so weird that you have like this shift here, right? What is the speed? What's like the range of speeds that we get? So we get training speeds of anywhere from 29,000-ish all the way up to 37,000. Okay. Episode returns. Yeah, we've got... These are very good. I need to figure out why it has this shape. And remind me, I don't want to tweet anything for a bit. I want Kyung to get some views on. Episode return of over 20 is sketchy. That shouldn't be possible. Could be some weird parameter settings. We'll have to go load up one of the policies, right? But what's like weird to me is that we have this one. Welcome. We're looking at some carb sweeps. Abhay. We're looking at these carb sweeps. We got lots of data and lots of good results from yesterday. We've got not this one. Where's the good one? Sweeps. This one. Recently got PufferLib working on the laptop. Nice. If you had any trouble or there were any bugs, let me know. I'm always looking to fix stuff. Why does this thing not load? We've got sweeps, though, for the MOBA and for Pong. And they look reasonable, but there's some quirks that I want to diagnose. And the goal is going to be to, to figure some stuff out. Maybe make a couple experimental tweaks here and there. But for the most part, this is going to be the routine for the next few days is going to be, look at and check on experiments a couple times. Just had to download CPU version for PyTorch. Yeah, that makes sense. Sweeps are automatically tuned hyperparameter runs. So like here, oh yeah, this is what we want. So right here, this is testing out different hyperparameters for the MOBA that we have. All these different hyperparameters, it's automatically tuning, and it is finding better and better settings for the training over time. And we can just see all the curves. So we can see that in this one here, which I think this is the best one, this one trained for 1.2 billion steps, and on average, each environment, it took like 59 towers over the course of that training run. So what you're looking for is the steepest line, basically. And then we get some insights over what hyperparameters are good from this as well. Now, there's still some weird things with this tech. How long do you run it? You can run it for however long you would like. This one, where is it? Not this one. So this one has been running for 5 hours or so, and it's done, I don't know, a few billion steps worth of experiments probably. And then we have this Pong one that's been running for like a day. Where is it? Yeah, we have this Pong one that's been running for like a full day, and this has 250 experiments worth of Pong. So we have way, way more data on it. So it just depends on how long it takes to find good parameters. What I'm trying to figure out right now is why we have this shape, right? Like it looks like, oh, look, it's getting better, right? Over time, and then it kind of just stops. It goes back down, and it takes a while to find the better settings. So I want to figure out why that is. That's the big quirk at the moment, I'd say. I wish there were like better tools for this. So created timestamp less than, or was this less than equal to? Is it possible to see it in action playing? These ones not yet. This is for, yeah, this is for the MOBA and for Pong. I can show you the MOBA in 1 second real quick. Not these trained models yet. I have to do a little work for that. 24.0. What the heck? 24. 31. Wait, what? July? Huh? How is it giving me? Oh, this is the time is uh 11:50, 12:01. I don't know. Something like that. What can I do now with Puffer on my laptop? Here, let me show you. So, where's our thing? Yeah. Let's see if this works. Check out MOBA. Diff. Hash. Let me try to get this running so you can see it. And then I'll show you some stuff you can do with Puffer on your laptop that should still be pretty fast. Let's get a compile. It's just recompiling everything since I switched branches. Okay, here we go. So here's the MOBA. We can run around. This is a support character. It's got a hook. So we just hooked this character to us. Oh no, we're taking damage. We've got an AoE heal. So they can't really do much to us there. We've got this nice AoE heal. I should be able to AoE heal up my teammates. There we go. And what do I have? I have a stun as well. So I don't know, where can I show off a stun? Here. We'll do like this guy here. He's going to chase me, right? Now he's not going to chase me. He's stunned. And we'll do the AoE heal. And now we're going to die. Nope. So there you go. Little MOBA. So that's the current state of this project. As for what you can do, if you're on the dev branch, I would suggest the snake environment. The snake environment is really cool. Let me see where I have GIFs for that. Let's see where we have GIFs. Should be on my page. They're probably pretty far down now, but... So the MOBA runs decently fast. You can even play with that on your laptop, probably. You can definitely play with Puffer Ocean environments. You can play with... Where is it? Oh yeah, these grid environments. I've got this thing. This is like a foraging env. You can play with this one for sure. When is the MOBA coming GitHub? It's already there. It's in the dev branch. All my work's open source. We've got all these fun particle envs. Looks like falling sand. These are in Ocean Grid. Not that one. We've got this little test. And then where's the really cool one? The snake env. Come on. Oh yeah, here. So this is like the snake env, right? So you can train snake very, very quickly. This is a nice test environment if you're not using GPU, because you should still get this running pretty darn fast. You can do small versions of it. You can do large versions of it. You can get like mega snake like this, right? So lots of environments you can play with. There you go. MOBA's on GitHub under dev. All the first-party environments are PufferLib environments Ocean. Back to analysis. Back to analysis. Okay, so these are all the early runs. And it's kind of hard to filter this. What if I just cut the top portions? So I just do greater than 15. How do I run them? There are docs on Puffer AI GitHub IO, but as you just saw me, demo.py, env MOBA, mode eval, and then there are different render modes. So like render mode human is usually the playable one. Then there's mode train for training. There's a vec option, multiprocessing. I try to make it very easy. So if you just do like -H, you get all sorts of different options here. Has a nice help menu. Okay, so what on earth happened here? Because this is really weird, right? We had an environment that was like at 18.5. Is it this one here? Probably this one, right? If it's 18.5. Yeah, this one. And then... Did it find something dramatically different? Is that what happened? With this one. Where it's like right above it. $5.19. Very weird. So this one, and this one. I think I should make this 18 just to make it easier to see. $18.5. Okay. So now maybe I can actually tell what's going on. You have these two purple ones. And these are, wait, 1903, 1020. Okay, so these are very far apart in terms of when that they were created, right? And this one looked very promising very early on. And then it took way longer to get this one. And eventually this one. This one's really the best. Why did it take this long? What is the utilization of CPU and I assume that's GPU when running an environment? CPU is going to be just about maxed. The GPU, it's going to depend on how much data you're feeding it. GPU is usually not fully saturated because data transfer times and stuff. The way we do our vectorization, though, when you do --vec multiprocessing, this sounds dumb, but it's not. There's busy waiting. The workers are actually busy waiting for more data. So they're basically always spinning. The workers are very, very performance sensitive. Like you have tens of microseconds, less than tens of microseconds, in which to have any overhead occur. Okay, so I see here that these are very different sets of parameters, right? So it looks like what happened is there are like two different distributions, maybe? Yeah. So like, hi Nathan, welcome. We're debugging hyperparameter sweep shenanigans today. Actually, if I just disable these filters, this will be really cool to look at. So I have this hyperparam sweep algorithm and it works amazingly. But for some environments, you get this weird behavior where like it finds a good solution early on and then it just falls off and then it takes a really long time to find better solutions. Like it eventually will find them, but it can take a long time. So I'm trying to figure out what's causing this. I wonder if they replied to my GitHub issue. What do you think are the chances we get a 1-day reply? Aw, no luck. What is the max time that you have run PufferLib? Like one experiment? I don't know, maybe like a week. If you mean samples, though, I've run like 100 billion samples in one trial. So that's probably close to a 100 billion. That's probably like 50. How many terabytes? That's a lot of terabytes of data. I think that's like 50 terabytes of data. That's a lot of samples, right? But when you run 1,000,000 samples per second, you can do that kind of thing. You kind of see the same thing here, don't you? Like, look at this, right? It's like it found some good ones, and then it stops for a bit, and then it goes back up. How do you store? You don't store it. It's reinforcement learning, right? The data is just in memory. Why store data when you can simulate fresh data instantly? If you wanted to run the environment at like 20 million steps per second, you can. What's the plans for PufferLib? I'm working on a video at the moment talking about like all this, like where I see all the stuff that Puffer's done fitting into fixing all the stuff that's wrong with reinforcement learning. I'm going to be working on that on stream later today. Puffer's actually in a really nice spot at the moment. Like, yeah. Puffer's actually in a very nice spot at the moment. Like, if we just have these sweeps working well and we have all these environments nice, is making multi-agent training fast the main feature of PufferLib? It's not just multi-agent. We make single agent way faster as well. We have a paper. So it's mostly fancy observations and actions, though it's more than just that. So here, like NetHack is single agent. We get NetHack up to 96,000 steps per second simulated. Gymnasium gets capped at like 7,000. Even in fully synchronous mode, we get 18,000. We get 55,000 compared to 11,000 on MiniHack. With Pokemon, we get 7.2 thousand compared to 5,000. For these more traditional M's, it's going to be a smaller gap, but still like 30 to 50%. For really fast environments, we get like millions. Other ones get capped to around 100K. With Atari, we're up to 25K. Gymnasium's at like 4.8 or whatever. And actually, as of the other day, I now have Atari running at 40,000 plus. I think 60,000 even. Crafter is fast. Mini grid 200,000. You get the idea. So we just make everything fast. We also make it broadly compatible. You know, it's really hard to use environments like NetHack and such without Puffer. Our emulation wrapper is very nice. And we also work now on high performance simulation so we can have better environments for RL in the first place. Next use case or game that Puffer will work on. We have a lot of stuff at the moment that just needs to be polished up and shipped is 1.1. Like the Snake game, the MOBA, the Grid Env. There's like two others actually I'm working on as well. So we need to have like a nice big simulation update. And we need to have the Hyperparameter sweep stuff working nicely. And that pretty much puts RL in a spot where you have ultra fast environments and automated tuning to run whatever you want. And that puts RL in a very, very good spot for research. We'll probably come up with some more simulators after that. And we'll start branching out to other problems like control, robotics, and whatnot. If I implement my environments, how can I make it work faster with PufferLib? Should I vectorize the env update themselves? I have a great example for you. It's in the dev branch at the moment. This is, I'll point you to the snake environment I wrote. It's a very nice, simple case. The techniques apply to more complex stuff like the MOBA I wrote as well. It's all the same. So here we have 229 lines of Cython plus 216 lines of Python. This implements essentially Slither.io, 4096 agent snake, or you can simulate 4096 environments of classic snake or anything in between. And the snake simulation runs at 10 million plus steps per second. So you get tons of data, and the training runs at 1 million per second. So if you're looking for like a way to get the most out of Puffer and how do you like write your own sims to be ultra fast, this is where you look. This is the simple example. And if you want something that's a lot more complicated, just to see that this tech scales, we've got the MOBA I'm working on, the project that I've been showing off, which is like 1,300 lines, right? And it's all the same. Is that 1 million steps with one CPU, GPU? Simulation is 10 million steps or so per CPU core. So that's single thread performance. You can get much higher with Puffer's Vec. One GPU, yes. For training, what we do is we'll use 2 cores because we buffer the data back and forth. So, while you're running inference on the data from one core, right, the other core is prepping data for you for the next step. So we use 2 so that you don't have any hitching. You're never waiting on data, essentially. But yeah, 2 CPU cores, 1 GPU. It's a good GPU. It's a 4090, but it ain't no H100. It's a consumer desktop. This is where we're going with Puffer. We're making all of RL easy, simple, automated hyperparameter tuning, and stupidly high perf. This is what we're doing. Welcome. How do I get the data from Puffer? What do you mean get the data from Puffer? The data is simulations, right? You run the sims. You mean the API? I don't really know if I get the question. But yeah, I really want to set us a new benchmark where like reinforcement learning on whatever we want is going to train at minimum hundreds of thousands of steps per second, optimized 1 million steps per second. And all the sims just run at millions of steps per second. And you can do this at home on a single desktop. And you have automated hyperparameter tuning, so you can run experiments overnight, come back, have optimal parameters. You're going to do research. You want to come up with a new algorithmic modification. You make your change, and then you run a full hyperparam sweep overnight. So you have comprehensive results instead of the thing now, which is like manually tuning hyperparameters over 3 months. What can I do with the data? I didn't phrase my question properly. With the data from the environments? Well, we used it to train the reinforcement learning algorithm, right? The agent plays the game. By playing the game, the agent gets better at playing the game, goes back and forth in a loop. And specifically with these environments, they're really good for tuning your algorithms, right? Let's say you're doing work and you want to know whether your RL algorithm is any good or your implementation is any good, or you have ideas on how to improve it better. This gives you a really, really fast way to do all of that. So that's the importance of speed, right? It's not so much you're going to take your model that's trained on snake and you're going to go solve cancer with it. It's more like you have this model that you want to go do something else with, but whatever problem you actually have to train on is really slow. So here you have a whole suite of environments that are ultra fast that you can test on, and then you can transfer the results over. How do we do the hyperparam sweep? It's in the demo file. It's in dev for now. Actually, the carbs is in the dev branch. The other ones are not. But we have this carb sweep. This is from Imbue AI. It's my integration with their implementation. And I got it working with WandB. So this is a fancy Bayesian algorithm that's better than the built-in Bayes by a huge margin. I have an article on X if you're interested in the details of that. Let me find it. Let me find the article. We have this article on X. It's really nice. And you can just run that and you'll get curves like this, right? Do you think Puffer is good enough for someone who's new to RL in terms of abstraction? Because I remember having to implement Q-learning and the environment from scratch due to no resources. Yes. The primary purpose of Puffer is not for beginners. It's to push the cutting edge of research. But the way that I do that is by making everything simple. So yes, it has the side effect of being very good for beginners as well. That's the nice thing about it. If you're familiar with CleanRL, CleanRL is what I generally recommend, even to beginners, over, say, Stable Baselines 3, precisely because it does not have a bunch of abstraction, and it's very short, right? You can have a huge stack of things that you don't quite understand how work together, or you can have just 300 lines of code that does everything. The 300 lines of code is going to be easier to deal with. Puffer follows the same philosophy there. Puffer is not primarily a implementations framework, so we don't do all the implementations. We do give you PPO out of the box that's very highly optimized, and it's one file, so it's very easy to read and follow. So that's where I'd suggest, if you're new, I'd suggest grabbing Puffer, looking at our CleanRL code, our CleanRL PPO derivative code, and running it on some environments very, very fast. Is WandB free? Yeah, you can get a free account on WandB. There's also a paid option. The paid option gives you extra storage and stuff. But you can get all this, everything you're seeing right here, you can get this all free. In fact, I just subscribed yesterday. I just started paying them a little bit yesterday because it's a good product and I could use some storage. And Puffer is absolutely free. If you want to help out the project, the best way you can help me out is to just star the repository. Helps me out a whole ton. Yeah, I'll share this. Actually, let me just link the whole. So this is Puffer on GitHub. This has the PufferLib, but there's also PufferTank, and this has my my nvim config. It's very simple. You'll be very disappointed. It just has Semshi and SuperMaven and a color scheme. That's all that's in here. But you can get it in PufferTank. Do you get storage with the free WandB? Yeah, you get 100 gigs for free. Is CleanRL on Dev or 1.0? It's on both. There's Clean PuffRL, which is like PufferLib's version of CleanRL's PPO. It's on both. Like, the dev branch is a bit less stable. I'm hacking on it constantly, but it has like our new sweep stuff and it has a bunch of the new simulations. So if you're resource constrained, right, if you want like the Snake Envin stuff, that's all on dev. The MOBA's on dev, all that stuff is on dev. And I do break stuff in dev quite a bit. It's not guaranteed stable. If something breaks, you just come chat with me on stream or message in Discord, right? And I fix it. The WandB free without it. Yeah, there's no trial. It's just free. You can just use it. It's not a free trial. You can just use it. Pretty darn sure, at least, right? I don't think you need a .edu either. I think it's just free. Are you more productive on Vim? I mean, minor, like, slightly. I'm generally just slightly less annoyed by, like, having to attach VS Code to stuff. You can use whatever you want. I would definitely advise against being the meme of configuring NeoVim all day. You don't need to spend all day configuring the thing. It's like, I have 2 plugins. How do I link it to Puffer? You don't have to link anything to Puffer. It's just in the demo file. There's like a WandB entity, WandB project. All you got to do is you put in your project name, your username, and then when you don't have to put your password in the file. What'll happen is when you run it with like -- track or whatever, then it will the WandB API will prompt you for your credentials and you'll authenticate through there. That's how Puffer works. Thank you to whoever just started. Helps me out a whole ton. The growth on this project has been amazing. Right here, this is where I started working on Puffer full-time after I graduated. And we've gone, above 700 just in the last couple of months, which is awesome. Really, really helps me to have this level of growth on stuff. What are you working on today exactly? At the moment, I'm kind of chatting. But what I would like to do is I have a couple of sweeps that I'm looking at. And where is it? So I have a couple of these sweeps that I'm looking at. And there's this weird thing I've noticed where carbs tends to like very quickly produce pretty good results. And then it drops off for a while. And then it produces good results more slowly over time. So I'd like to understand what's happening here and how I can, make this happen faster. Did you improve the DM Lab FPS or other camera rendering env? I improved Atari a whole ton. I have Atari right now. If you want to see this Pong sweep, I'm actually pretty proud of this. So this is Pong. I have this training between 30 and 40,000 steps per second on Pong, which is like 5 times faster than is normal at the very least. All the training you're doing now is here. Let me get this so I can actually read the chat, because I have like too much stuff behind the chat. There we go. All this is MAPPO. It depends what you mean by MAPPO. It is PPO applied independently to each agent, sharing a single set of weights. So I don't know if that's IPPO or whatever. It's just PPO. The MA stuff, like, people got a whole bunch of the names confused. Only found you recently in June due to the Pokemon Red video. Found the Discord, found Puffer, and started watching your streams. Wish I found it earlier. You didn't miss much. I haven't been doing this for very long. I just graduated. I just graduated this past spring. So now, I've defended the PhD and free from the shackles of academia. I'm fixing reinforcement learning. I'm fixing all of the things that have bothered me about reinforcement learning that I have not been able to do because it doesn't make sense to do in academia. And it's happening very, very quickly. Like, the progress in the last couple of months, like, as soon as these sims are fully polished and live, I think people are going to see that reinforcement learning is a different field. It's just a completely different ball game with the speed that we have access to now. Full-time streamer life? No, this isn't full-time streamer. This is full-time dev. This is not content creation. The streaming is just nice because, like, I'm working on an open source project, and this is a fun way to, like, chat with users and chat with people that are interested in this stuff. And it actually ends up keeping me more focused because, yeah, I spend time chatting like this, but I generally have a very hard time focusing most of the time when I'm just working on my own. So the time that I spend chatting is just the time that I would spend zoning out while working normally. So, yeah, this is just a better way to do that. How's your PhD? Good. It's 5 years. I'm glad I'm done. Loved your thesis defense. Thank you. I'll show you a little sneak peek of what I've been working on lately. This is new. This is going to be the second long form talk on the channel. I really just want to kind of go through my whole thoughts. It's going to be very opinionated. It's not going to be as academic, but I really want to go through everything that is causing reinforcement learning to not be a widely used tech and how I'm fixing it with Puffer. That is going to be the talk. So I'll be working on this on stream in a little bit after I'm done chatting here and after I figure this out. This weird sweep. I wish there were like a better way to... I'm trying to think how I can track this over time. Loved it too. Thank you. It was kind of crazy how much that video blew up. Like, I gotta say, it's really nice to have something like that catch on and gain recognition, because the type of stuff I work on, it's not a fun thing to work on in academia. Like, you're really, really fighting upstream with this type of work, because it's more heavily engineering. It's more heavily like infrastructure and stuff. And that is not the type of thing that gets people excited in academia. How much RAM do you have? I also started writing articles because they let me like give really good answers to all the repeat questions I get. This is on the website. This is the puffer cluster. We've got 8 4090s, one per box. We've got 24 cores per box and 128 gigs of RAM per box. All the specs are here. Puffer cluster. If you're interested in written form content, I post the best articles of mine to the Puffer blog, like Puffer AI, GitHub IO, and then I post like some random stuff as well as X articles. So, I've got this one. This is the same article, just mirrored to X. This is a for fun article. I've got hyperparam tuning, so I've got 4 of these so far. About the 10 mil steps per second you mentioned, can you clarify how it scales with number of CPUs, GPUs, and if that's sim or M steps? Sim steps are M steps. I'm not sure what that means. That is single-threaded. So that scales linearly with the number of CPUs that you have, except that in order to actually make use of that data, you have to have a really good vectorization implementation. PufferLib has the best vectorization implementation in existence. I have not actually profiled how fast it can be at the high end, because at the moment it's ludicrously fast to the point that it doesn't matter. When you train Snake with 1 GPU and 2 CPU cores, you have 0% time spent on the environment. You're never waiting for data. You have 100% of the time is spent on either data transfer between GPU and CPU or on running the GPU. That's it. I bet I know what's wrong with this. Simulating versus training. 1 mil train throughput, 10 mil per core simulation throughput. So that means you're GPU bound. S1 GPU. Oh, I think you asked about GPU scaling. I have not done multi-GPU configurations yet because most people are training on like single node boxes in RL at smaller scale. That is something we will be doing in the future. But my thinking was RL is so cursed that nobody can even get it working efficiently on one GPU, like a one node setup. So, we're gonna wait until that is solid before I invest in bigger hardware. That stuff's expensive as well. Like, I'm gonna have to get some more serious funds if I want to scale to that. Like, anytime you're buying hardware that's not desktops, you either build it yourself or you pay a huge markup. So I will see whether I want to be building stuff myself, or the alternative is you just run more experiments, right? You just buy more single GPU boxes, and then you run more experiments on them, which is what I did with the Puffer cluster. Boxes are only about 4,000 a piece. Planning on getting the 5,000 series GPUs. Not initially. Not initially. The hardware has a lifespan expected of 2 to 3 years, and then after that we upgrade. Not super clear on how this works. So each pair of CPUs collects 10 million steps per second, and the GPU does the training, so you're capped by GPU through. Yes, exactly. Exactly. Now, it doesn't simulate 10 million steps per second, right, if the GPU doesn't keep up. It simulates, if you just run the simulation goes 10 million steps per second, right? But the way it works with the GPU is that you have the environments on each core, right, 2 cores. They simulate a batch of steps. You have 4096 agents each, usually, or 8,000 agents each. So you have like 4096 steps of data on one CPU, 4096 on the other. Hey, Will, is the agent good yet? Yeah, I've got some cool stuff to show you. 1 second. So you have 4096 agents on one CPU core, 4096 on the other CPU core. The GPU takes the data from the first core, right? And then the GPU takes the data from the second core. And while the GPU is taking data from the second core, the first core has already run the step, so that by the time the GPU is ready for data from the first core again, that's already done. So it is asynchronous sampling. If you want the technicals of that, it is still on policy learning. It doesn't cause any other issues. This is a technique that's taken from EnvPool and Sample Factory, if you want references. So, Will, we've got really cool stuff happening here. We've got tuning working. This is the total number of towers taken over the whole course of training. So we're looking for steeper and steeper curves. They are taking towers and winning games. This is a sweep that I started running this morning. We're getting optimal hyperparameters here. And to test carbs, I also have a sweep running on Pong. It's a little weird. I'm trying to figure out why it has this shape, this distribution shape. But it looks like we're going to be able to have this thing find a set of hyperparameters that solves Pong in like less than 5 minutes on one GPU. So that's nice. We doubled the train throughput of Atari the other day as well. My current guess with this is that this is like one distribution of parameters or something. It found like a distribution of parameters, and then probably this found a distribution of parameters, and then it needed to find a different one to get it to get any better, something like that, right? Also, why is this cut off? Any visualization of the current best policy? Not yet. I do have the game. Wait, the game is much nicer to play now, though. I made it feel a lot better. It's hard to show because it's more like how the game feels. Where's this thing? Which terminal? This one? Okay. So here we have the game. You follow around with the cursor. You have Q, W, and E. Q is a hook. We're going to hook a puffer. We just hooked a puffer over. We're getting hit, so we're going to use a AoE heal on ourselves to heal back up. We also have a stun. We can like say, hey, puffer, come follow me. And then we can say, nope, you're getting stunned, and leave him there. There you go. I want to see those agents take towers. You'll see them soon. We're very much experiment bound at the moment, so the idea is going to be on stream these days. I'm going to chat a little bit with people. I'm going to go through experiments. I'm going to see if I can make tweaks to carbs, and then I've got another talk that I'm working on a video or a talk. I'm doing that just on stream because why not? New to your channel and work. Can you explain to me the relationship between MOBA, Dota, and League? The relationship with MOBA. I recognize the minimap, map design, creeps, heroes. Yeah, so this is the idea of this project. Actually, here, it'll be easier if I show the high-level view of this. Let me show you. So this is it at a high level, right? Looks like a MOBA at a high level. It's the idea is that it's going to be mini Dota. It's not going to be one-to-one. It's simplified enough that I can implement this as a single person relatively quickly, but hopefully you can still get some of the same high-level pushing strategies, right? Split push, some of the same high-level strategies. I didn't replicate everything exactly. I did replicate the tower locations, the spawn positions, neutral spawn positions, and some of the stats. I have not added fucking trees yet, Will, because that takes, time and code, and there are other things that need to be done first. But yeah, I read some stuff from the game client, and then I just came up with others. You realize that in order to add trees, I have to do a really obnoxious pre-computed vision mask, right? Like, I need to do a really obnoxious connected component scan in order to do that. Yep, towers are the yellow dots. Final, make a PR. Is this still any config? It's in the dev branch now. You can go ahead and try to make a PR, but you realize you have to pre-compute it, right? You have to pre-compute the connect. You have to read the data, the tree data from this other repository. So you have to go read tree data, which isn't that hard. But then from there, So you cannot do that if you want. I'll read the actual tree data if you want. But then you need to do like connected components on the trees or something like that. And you need to pre-compute that because there's no way in hell you're doing that at runtime. That's way too slow. Rendering trees and all gotta be... We don't really care about rendering cost. We don't render during training. So during training, what they get is they get local state. So they get the data that would go into the renderer to produce that. Yeah. Well, the target is 1,000,000 steps per second single thread. So, yeah, stuff's got to be fast. You can totally get that with a mask, but you have to be clever about it. Had to look at the code and I'm impressed. Thank you. This is a new project, right? This is week 3 of doing anything with this MOBA. This didn't exist 2.5 weeks ago. We should do a chat bet to see what the odds are that Will comes up with a decent PR for a relatively complex feature on this crazy project. What's the issue with carbs? I didn't get it. You see the shape of this? It doesn't just go up over time, right? It goes up over time and then it crashes down and then it goes back up over time. Kind of weird, right? Okay, gotta go. See you later. Keep up the good work. Thank you. Created timestamp. What if we do uptime? So this is the Pareto front. What is that distribution though? This? Well, they're going to be... The uptimes are going to be very similar for a lot of different configurations, right? Like if you double the batch size, that'll be roughly this. It'll take roughly the same amount of time for everything that has like the same batch size or whatever. There are not that many hyperparameters that influence runtime. No, the other one that showed what's the sudden dip with carbs? Yeah, that's the question. Are the MOBA agents LSTMs? Yep. It's a little CNN plus LSTM. CNN over local state, not pixels. All the code's public. It's all on dev. The MOBA source is only 1,300 lines. Kind of interesting Pareto front. What's the local state for the agent? It is a... Let me show you. You can add a channel to this if you need to for like vision or something. I don't think you'll need to, but if you need to, you'll be able to. I think that you'll just be able to do it. You'll just be able to like compute. Hold on. Surprised you do CNN over local state? Why wouldn't I? It's 2D. I cleaned this up quite a bit, so it's pretty good now. There's also a branch that's called MOBA that has some new stuff in it, but I don't have models training on that yet. It's pretty close to this anyways. If I knew what local state was, so here it is, right? So you get the first channel of the observation is the grid. The grid data has a set of indices for all the different types. So you have 16 different types of indices here. These are going to get one-hotted in the actual architecture. And then these are extra obs. So this is a flat observation for just the hero character. So you get like the CNN map, plus you get an extra ob for a linear layer. This is all in there. And then there's some additional channels to the conv map that include the health of nearby, the percentage health of nearby agents, percentage mana of nearby agents, and the level of nearby agents. Spatial. There you go. It's a pretty small network. It's like 150,000, 160,000 parameters. Same network I use for Snake and everything else. It's a very nice compact design. Has an LSTM. Will is about to either submit the most cracked PR I've ever seen or like complete cursor slop, and I have no idea which one. This could be the thing that sells me on cursor. We'll see. I'm just messing with you, Will. What is the logic of the .py versus .pyx files? Python lets you run all this in native C. So the whole simulation of the MOBA is it runs in native C without calling back to Python. This makes it between 20 and 100 times faster than a native Python version would be. Is there terrain masking? Or do all the agents know the location of enemies all the time? They only see stuff that's nearby. They only see a nearby crop. There's no vision masking at the moment, so you can see behind walls. But yeah. Oh yeah, technically, Will, if you wanted to, instead of doing connected components, you could literally compute a vision mask for every single tile on the map, right? You could just compute a vision map for every single tile on the map. That wouldn't be that much data. You can look at the pathing pre-computation I did. That's way more data than this would be. Cursor. Okay, be right back. Does dev branch support continuous actions? Yes. Yes, it does. It's a relatively new addition, so you'll have to tell me how it works. But we do have a test end for it. We have this nice set of grid environments that have reasonably complicated tasks in them that can be run either discrete or continuous. So, you can actually figure out from there whether it works discrete and not continuous, or for whether, your algorithm is bad or whatever, and you can run sweeps. We have somebody actually working on testing that stuff now, but it's in there. Pong. Will fam, I'm rooting for you. Thanks. For MOBA, you're discretizing the action space. At the moment, we are. I don't know whether I will find, like, ultimately. I might make the movement continuous and the rest of it, the button press is obviously discrete. It could go either way, right? Okay, this is not telling me anything. Let me, real quick here. If I put this filter back on, right? Not this one. This looks to me like they're different distributions, right? The basic idea for the tree thing to create like a binary mask for the grid to know if each grid point is a tree or not. It's more than that. It would be to have a binary mask, so from every position on the map, you have something to tell whether you can see, like if there's an obstacle in the way, right? You'd have to like compute the vision mask. So you pre-compute all the masks. So if you're in the trees, you know, you can see out of the trees, but things can't see you in the trees, that type of a thing. You know, it occurs to me that the thing that this could be is just what 18.95. So this it's this one here, right? What are the hyperparams for this? Repeat action prob over here, okay. BPT horizon 8. Clip coefficient up here, that shouldn't matter. Relatively high entropy, maybe? Not that high. JE, relatively high. Gamma, relatively high. Very low learning rate. Mini batch size, high. 2 update epochs. And then in order to get this thing to work really well, we lower the repeat probs, the batch size. It's like a very different set of hyperparams. That's very sketchy. So I guess what this says is that if there is a distribution, if there's like a better distribution of hyperparams, carbs will probably eventually find it, but it'll take a while. I'm pretty sure this is what happened, is that it's just like multiple distributions. Can I see it over time if I like take this filter off? If I just make this graph really big. You have all these runs up here. And then you have these runs, which look like they have better outcomes down here. What if I just filter the really bad runs? I filtered out the really bad ones. Like... Now can I see? I'm just trying to see if I can see like a distribution shift occur. So many of these right here with this value function coefficient. We've got like these ones that use a lot of compute that all do well. Is there any parameter that I expect to be very sensitive? The entropy? Or is it this repeat action prob? No, I have good runs at like lots of different probs. Learning rate. Got a lot of good runs at lower learning rates, don't you? Runtime is the most important parameter. Value function clip coefficient is important. That's weird. I wouldn't expect that. And the other ones are not that important. It's weird. Of course, this is over the filtered runs. What about over all the runs? Over all the runs, we get a nicer spread. The mini batch size being more recognized. But then among any of the reasonable runs, Can I see? Let's go back to this viz over here. Oh, these are all longer runs, aren't they? So these bottom two. Oh. Well, that makes sense. Hold on. These are all longer runs. And these are all shorter runs. So what was happening here? It was plateauing. Why would it be plateauing? That's really weird for it to plateau, like just shy, right? Okay, so the carbs is not stupid. There's something genuinely weird happening here, right? Because it was making these runs before very early on that were doing very well, but were kind of pittering out at the end. Is it? 0.08 repeat action prob. Point 0.08 repeat action prob. How about the other ones? Does it go down? Come on. So stupid. Where'd my sweep go? Okay, here. Wait, what? This is not true, right? Episode return versus created? Oh no, I don't know what happened here. Something weird happened. Pong. I think we're making some progress. I have some ideas now. So these runs have a repeat prob up here. The best run has a lower repeat prob, but this one, that seems like it is possible to do better. You just have to train for a long time. What is this one? Why is this freaking broken right here? I want this to be working so I can click things. Okay, this one, I want to click this one here. Okay, so this is 19.5 or whatever over here, and then you just keep running it and it gets to 20, right? $19.8. Where's this one? 18.6. This one's here, right? Doesn't train very long at all. These curves look like. These all look like they work, right? It's hard to say with this green one. No, it looks like it's working. It really does just seem like it takes a while for it to discover like a different distribution, I guess. It's very weird. Let me check a couple things. They're docs. Mode, difficulty, frame skip, Mikado. It's this paper, right? I remember this paper. Diverse the evaluation methods have become with time. I'm looking for where they do sticky actions. Bunch of garbage math. This is funny. So this is not what the majority of rappers do. I think this is garbage. This is terrible advice here. Full training episodes on a fixed number of frames. Taking the number of skipped frames into consideration when measuring training data. We advocate taking the number of skipped frames. That's weird. Summarizing learning performance. Okay, this is it, right? No, the original Atari had no source of entropy. It's fully deterministic. It's possible to achieve high scores by learning an open loop policy, simply memorizing a good action sequence. Various approaches have been developed to add to this. Recommendation is to use sticky actions, which we discussed in section 5. Okay, that's what we want. We don't need any of this. Okay, this is what we want. This is the thing that makes a difference that we need to read so that we have this right. Okay, so this is what I'm using. Where do they give the details of this? Is there an appendix? Okay, this is here. Okay, so here we actually have their evaluation of sticky actions. This is what we need in order to tell if we should be, how we should be treating that parameter. Okay, so essentially what they're arguing is they're arguing that this thing only impacts dumb algorithms, so we should use it. But is that actually true? What? Wait. We can see that the brood is the only algorithm substantially impacted by sticky actions. Table 2 depicts... We repeated the experiments 5.1.1. Okay. But with sticky action 0.25. We can see that the brood is the only algorithm substantially impacted by sticky actions. What is this parentheses? Standard deviation. Okay. So this crashes it completely, yeah, as you'd expect. DQN is not impacted. It's impacted a little bit. I really don't like this method. Initial no-ops. Random human starts. Uniformly random action noise. May interfere. Yes. Random frame skips. Agent has perfect reaction time. Restricts agents to using frame skip. Does not interfere with action selection. Discounting must also be treated more carefully. Asynchronous environment. Lacks repeat. Okay. New benchmark results using sticky actions. It's really obnoxious the way this is introduced. Setting a model learning. It's fine. Exploration. Modes and difficulties. A default game mode and level that could be changed. Any appendices? They use the full action set. 18 actions. Hmm. The question is, do I trust their results? They don't have this ablation, right, with and without their sticky actions, do they? Okay, so we got to go back to this table and make a decision based on this. The problem is that I do not believe these results here. Or at least I don't believe that these will apply across the board. Quite substantially affects Asterix. There's an effect on Beam Rider. There's an effect. Does better on Sequest and Space Invaders, which is weird. I would think that this would be game dependent though, right? Maybe I should look at this in here. So here's the repeat. Let me see. So across all of these trials, negative correlation. Oh, well, this is interesting. Do I have no good results at 0.25? I should be able to plot that, right? Repeat. No good results above 0.12. It's pretty conclusive. Do I have the sweep from before? So the thing I'm worried about here basically is like, you have to win like 20 rounds of Pong, right, to solve this environment. And what this sticky action thing does, especially with frame skip, is sometimes it just ignores what you want to do and like holds down the key. So I don't think I could win Pong with that, right? 25% of the time, you just don't get to do what you want to do. And then 16, you know, what's the Atari frame rate? I don't know what the ALE. 60 FPS. $60 frames per second. And frame skip. So with frame skip 4, you're running at 15 FPS, right? How bad is it to lose a frame on a 15 FPS game? Well, let me think about, here's another way. Let's think about games where this changes your strategy. It's like all of them, isn't it? You're not allowed to catch the ball on the edge of the paddle. Or actually, you want to catch it on the leading edge of the paddle, so if you accidentally frame skip, you don't go past. Or you want to get the paddle into place, and then you want to, like, pass. What does Gymnasium SB3 do for this? It's like researchers inventing problems for themselves. Holy hell. So, max and skip env. Where's this? Frame skip. Yeah, this is frame skip 4. Max and skip. Episodic life, clip reward. There's no sticky action here, is there? Yeah, no, they're doing the no-op resets. Maybe Costa has results. What's this guy's name? Mikado? That was my paper. Machado, yeah. What's he running in his latest stuff? There's no Mikado in here, right? Yeah, this still SP3. Well, that's obnoxious because I have to use it now, don't I? They set this stupid parameter way too high. I hate when I'm faced with these types of choices where it's like, in my mind, the right thing to do is to ignore this stupid thing. Or if you're going to use it, you set it to something very low. Like, you're sabotaging your ability to play the game. He did report Let me see what he reported. I'll decide based on this. Let me look at some scores. Where's Pong? You gotta be kidding me. What's this dagger here? What's the dagger? The games originally used as training games by each method. Okay, so now I have a way to do this. DQN, paper. $20. Okay, so I have something on them now. I have something on them. I think I found yet another fucking crazy broken thing with RL. If I'm right, this is nuts, and this is so stupid. It's like a best practices paper introducing worst practices. Let me see. So, wait, this is Sarsa. Okay, wait, maybe we're okay. DQN. Across 60 games. How many frames? They have better tables? They don't have better tables. Fuck. So this is all we have to go off of. What environments did they use up top? Beam Rider. They do have Beam Rider. Okay, so they say that their implementation outperforms the original here. Right? Did they use 200 million frames? $10 million frames. Where do they say how long they train? Epochs? Mini batch weight updates. Do I actually have to compute this? Is it this obnoxious? How many frames did they train for? $32. Okay, so I can compute this then, right? $32 mini batch size. 100 epochs. 50,000. 160 million frames. Okay? 160 million frames. which if they use frame skip 5 should match pretty much perfectly. So I'm going to take these two papers as comparable directly. We might just be about to find it like yet another crazy catastrophic RL fuck up. It seems very likely at this point. Wait, didn't they do Sequest in the original paper? They did do Sequest. And they get 1705. Oh, and Space Invaders. So their implementation gets 1397 with DQN. The original gets 1705. They get 4.76 on Beam Rider. So they outperform here. There's no freeway. Sequest, yeah, and then Space Invaders, they report that they do better. So I'm going to say that they have a comparable implementation. They have a comparable implementation to the original here. And then they report that Beam Rider does not degrade substantially. Sequest does better. And Space Invaders does better under this scheme. Asterix notably does worse. But we have to look at the other algorithms, the other ones they didn't report. Wait, what is this? Results on ALE's original training set using DQN. What's this? DQN has much higher variability. Yeah, but this is fine. We don't care about that. So now what we do is we go down to the bottom here where they have their full results and we compare their full results to the original DQN environments. And we see whether they hit any skeletons in the closet. So they have Sarsa here. It's technically, I think it's a different Sarsa though. I think we mostly care about DQN, don't we? Pong gets to 14.5. They say Sarsa gets to... They say their Sarsa doesn't work. Okay. The original Sarsa they say doesn't work. But this is a different Sarsa. So do we even bother comparing this? Beam Rider 2.2. Yeah, okay, so these are completely different then. So we don't compare Sarsa. We just compare DQN. We don't have a ton of data here, but maybe we have enough to find skeletons in the closet, right? So Beam Rider gets up to 5.7. So they say that this is very good. Really, we should look somewhere between these two because they used 160 in the original paper. So yeah, they do a bit better than the original paper, it looks like. Fair bit better. Okay. And then Breakout. Breakout, I guess they say, is unstable because they get to 75 and it crashes. Breakout gets 168 in DQN. does better. So they did hide skeletons in the closet here. They totally failed on one of the original ends. Let's see if they have failed on other ones. Let's see if they just cherry-picked. Enduro. They get up to 688. Okay, to their credit here, they don't appear to be cherry-picking on this one. They appear to get good performance. We would probably take somewhere like 650-ish, somewhere around here. Pong. Pong is known for being like the most consistent task. They do not solve Pong with their method, right? Am I on the right column? Yeah, they do not solve Pong with their method. DQN solves Pong. And it solves Pong consistently. That's a big skeleton in the closet. Q Starbert. 9.8. Decay, they say they do very well on Q Starbert, whatever. There are going to be some implementation details. This one's a very sensitive env. Sequest. I think they reported this one as well, 1.4. Okay, and then Space Invaders. 800. Okay, so the two that are just very suspicious are this paper doesn't work on Breakout and Pong. Right? This paper just does not work on Breakout and Pong. So why am I going to trust? And Breakout and Pong are like very long episode games as well, right? Where like you can, missing an action at any time can screw you over. So why am I going to use a best practice from a paper where they don't compare, you know, they happen not to compare on these two of the original 7 M's. How many do they compare on the originals? Two. They compare on 3 out of the 7 M's. And on 2 of the ones that they don't, which happen to be like the 2 widest known ones, it completely diverges. What was the best result that I got? This is another question. What was the best result that I got for Pong here? If I go like this, right? And I set this to repeat action prob. Not that many experiments, but didn't I have an earlier sweep as well? I think I had an earlier sweep that I can look to. Let me see if I can find it. Sweeps. 2 weeks ago. This Pong. This is a MOBA. Didn't I have a different sweep on Pong? Maybe it's still a carb sweep. Run, count, and compute time. Is it this one? Yeah. So this is before I fixed the repeat action prob. Do I have enough evidence to make a thread on this or no? Or should I run? Do I want to spend a whole day on another run of this? I mean, it really would be nice for the conclusive, right? I think that I should not make a thread of this right now. The responsible thing to do is going to be to run one more set to confirm. But to folks watching, let me explain what I just found and why it's like potentially a huge deal to reinforcement learning. Every so often somebody makes a big stink over evaluation methods in RL and like whether we're doing good science, which is fair because we're usually not doing good science, right? And then they'll introduce like a new guideline or something or a new practice on how to do good evaluation and reinforcement learning. So this is one of the best known papers in this area. It's the Machado paper, whatever. And one of the big recommendations that they make is that, where is it? Sticky actions. What the heck is sticky actions? Right here. Sticky actions are very simple. 25% of the time, when your agent makes an action, it instead repeats the previous action. So it's like, you're pressing buttons on your keyboard, and then 25% of the time, the last one's still stuck down. And they say that in their paper, this does not create a substantial performance difference if you're using any reasonable algorithm. So if you're training DQN, doesn't make a big performance difference. SARSA doesn't make a big performance difference. Only affects brute force algorithms that are attempting to exploit the lack of stochasticity in Atari. So they introduced this new thing. And a lot of people have used this. It has like 600 some odd citations. But if you think about it, wouldn't it seem like in a lot of games, if your buttons are sticky, that's going to make it really hard to play the game no matter how good you are? Would seem like it, right? And I've noticed that with this new wrapper, it's been kind of hard to train Pong. And actually, if I go into my sweep data here, I can actually see that there's a negative correlation between this probability, because I swept over it. There's a negative correlation between this probability and how well you do at Pong. Let me prove that to you. Real quick. I'll prove that to you. Okay, so here are all of my runs. Here are all of my runs. Here's the action repeat probability, negative correlation with performance. And the much more striking example is that if I simply make this axis repeat action probability, you can see that above a repeat action probability of 0.13, this stuff does not work anymore, right? You don't get high scores above a repeat action probability of 0.13. which what I would assume would mean that when you have a repeat action probability a heck of like a 0.25, and this can accumulate, by the way, like 1 in 16 frames, you're going to be stuck for 3 whole frames on the same action. I would assume that in a game as long as Pong, where you have to win 20 rounds in order to have solved the environment, that's going to cause a problem. So what I did is I went through the original paper. I have side-by-sided both of these papers. Where is it? I side-by-sided the DQN paper. This is the best-known paper in reinforcement learning, with the Mikado paper, which is one of the best, also one of the, not anywhere widely as near, but a very influential paper. And I looked at their evaluations, right? And Sequest and Space Invaders were both used in the DQN paper. And if I look at their implementation and I look at this, the results here, it looks like their DQN implementation is about on par with the original. Okay? But when I scroll down to the appendix, we get the skeletons in the closet. They have their full DQN results. And included in here are 2 of the best known and most consistent environments in all of reinforcement learning. We've got Breakout, which their DQN implementation completely fails on. They only get a score of 70. 168 in the original paper. Pong, even more consistent of a task. You can solve this thing in like 2 million steps with good hyperparameters. They get a highest score of 15. The original paper from years before gets 20 consistently with DQN. Apparently there's like a 21st point or something. Something's weird with that, but 20 consistently. So what I think has happened is that they've made this suggestion, completely screwing over like really long games where eventually you're going to get screwed over by that one action. And nobody's bothered to call this, right? Nobody's bothered to call the paper on this. So what I'm going to do is, I was thinking about making a big thread about this right now. But I'm going to wait. I'm going to be responsible and I'm going to wait. And what I'm going to do is I'm going to let this sweep, this Pong sweep, run a little bit longer, the current sweep that I have. And then I'm going to run a Pong sweep where we use repeat action probability of 0.25 consistently. And if we can't solve Pong with that, or if it's way harder to solve Pong with that, or anything like that, anything of that matter, then we make that thread. Then we go make that thread. And we'll have made a very big contribution to reinforcement learning, because this would be a huge, huge oversight. And it's the exact type of oversight that you could make, right? It's like the type of oversight you would make by not thinking too much about the games as games and thinking about them as like math problems to be solved. Because if you think about this for a little bit, it's kind of obvious, right? That like, if you screw with the player's controls in a really long game that demands precise inputs, eventually they're going to lose because of it, right? Okay, well, how's our sweep going at the moment? This still doesn't answer, by the way, it still doesn't answer perfectly why our sweep has this weird shape. This doesn't answer perfectly why our sweep has this really weird shape to it. Let me find it. Right, we have this weird shape. I think this is probably just it being like multimodal and taking a lot of time. I think you just need a better initialization for that. So we're probably going to want to do some work as to where how carbs is initialized. It does eventually work though, which is the important part. And we can actually see now that we've given it enough time that we have all these nice consistent runs that are around 20, right? I wonder if it's going to find faster ones as well. Because what it should be doing is it should be finding more computationally efficient ways of doing this now. I mean, if we're looking at like 19 as solved, maybe, we're going to get definitely something that's sub 10 mil without the Mikado being too finicky. It looks like there is actually a little bit of stochasticity that it likes to have from this repeat action prob, which is kind of weird. The fact that it hasn't driven this all the way to 0 is kind of weird, right? We should probably disable it at evaluation time, maybe. Or not. I don't know. It's probably fine either way. Okay. Well, what I'm going to do now, we've done a lot of good analysis here. I'm going to go check the MOBA real quick. And then it's 211. Yeah, I'm not gonna take lunch just yet. I'm gonna take a couple minutes and then I'm gonna come back and do some more stuff. So what's going on here? Nothing's beaten this one yet. This purple one. I think it's looking for like shorter runs at the moment. Yeah, it's looking for shorter runs that do well. And it hasn't found any just yet. Yeah, this one won't be Pareto optimal. But the runs are working. This is good. Okay, I'm gonna be back in a minute or two. Clear my head out, and then I'm gonna start working on the well, the video thing, the talk, I should say, upcoming, the upcoming talk, and I'll just storyboard that, and I'll work on all of that stuff and answer questions and whatever else. Be right back. Okay. Well, I did not expect to find something of this magnitude today. That's kind of nutty. Let me message Costa real quick. 1 second. Let's see if he knows about this. Actually, this can be public. Who cares? All right. That's like a big if true finding though. That's a really big if true finding. Maybe Atari is actually not a terrible benchmark. Like, maybe Atari is not a terrible benchmark. Maybe we've just like shot ourselves in the feet repeatedly until we didn't have any feet left. Is there one of these? I thought there was a doodle of this. Foot. Okay, there isn't one of these. I thought that it was going to be one of these. I guess this is the closest one. Nah. I thought there was going to be a good meme. These are not. These are too edgy. I was going to post some bait on X. Let's do some real work then. So this is the other thing that I'm working on while I wait for experiments like this to finish. Working on this talk. I made the schedule for it, right? Yeah. So I'm going to keep storyboarding this. And I'm going to start making some slides. the goal is to start this. This is a talk that I'm planning on giving, and it's going to be like the second long form video. I'm doing it on stream because why not? This needs to be called the RL cake. No, this is the RL iceberg. Yo, Will, I think I just found like a huge, massive fucking 6-year-old problem with reinforcement learning. I think I just found an error with the Mikado paper. That sound like it would be big? So, the main thing with the Mikado paper, right? They spend a lot of time, they implement this sticky action thing. Where is it? They add this sticky action thing, right? This is what they say, that you should use 25% chance of repeating an action. All right, and they say that, where is it? They say in this table down here that, look, it doesn't hurt performance, right? It doesn't hurt performance unless you're using a stupid deterministic exploiting algorithm. Yeah, you should be familiar with this, right? So, the thing is, of the original 7 Atari M's, yeah, they only have Sequest and Space Invaders, right? Well, if you scroll down, they have full reports on everything, okay? And then if you match this, if you, do the red string diagram, and you match this to the original DQN results, you can see that they roughly match on the environments they said before, but on 2 of the most consistent environments out there, they fail Breakout, and they fail Pong. Both of these are long horizon environments in which you would kind of expect that if you're messing with the user's controls, eventually for Breakout they're going to screw up and like miss the ball, or for Pong they're going to miss a point or two, right? And this was like a technique that was introduced supposedly to like fight against some weird determinism thing that, if you think about it, nobody actually ever showed was a problem. Right? I think that this paper might have actually broken RL. Like, this paper might have broken Atari. That would be a big finding, wouldn't it? I think that would be a pretty freaking big finding if, like, the ALE Pi standard setting breaks it. Right? Oh, and when I ran my sweep, look at this. I ran my sweep and I actually gave a repeat action prob as a searchable hyperparameter. There is not a single one of these trials in this sweep of 200 and something that has over 0.13-ish repeat probability that does well. So I need to run a sweep. I'm going to tomorrow, or like overnight, I'm going to run a sweep where I fix the repeat action prob to 0.25 and see if I can solve Pong. But if I can't solve Pong, and that's the only change, then this paper is broken reinforcement learning, right? That's what I'm thinking. That's a pretty big finding. Yeah, well, broken multiple M's in the most common environment suite, right? Broken multiple M's in the most common environment suite. It's used in like 95% of papers. The amount of Atari shenanigans I've found. You want to see some fun curves on these? Relative time process. Let's see how long it's taking to solve Pong right now. About 5 minutes, I say. 5 to 6 minutes for our best run to get like 19 point something score average on Pong up here. I think we can go maybe here, like, so 5 minutes. Pong in 5 minutes on one GPU. Yeah, it really helps when you can train at 30 to 40,000 steps per second. It's just PPO with good hyperparameters and with good vectorization and like non-shitty env wrappers. With DQ, it's not just the algorithm. Like, so what's this? 10 minutes is 10 mil is like 8 minutes or whatever is that? So 80 minutes, 160 minutes. So less than 3 hours for the 200 million frames with this implementation. The funniest thing is we don't even have better sim tech. This is just Puffer, like, taking garbage all out of the existing ecosystem. I just removed some garbage wrappers and then did my own better vectorization thing, right? This is not the norm. Like, this is not in other libraries. I mean, this is not using, like, I'm not using C++ vec or anything here. This is not like the endpool binding. This is not like the official endpool binding, and this is still 30 to 40K. You have a PPO, Impl and Puffer. Yeah, I have, well, it's based on CleanRL's PPO, but it has, if you've seen it, it has a ton of optimizations in it. There's a ton of optimizations. I think that the fastest you would get the actual CleanRL one on this would be like maybe 12 to 15K, something like that. This is definitely going to be like at least twice as fast. If we get the full graph here, you can see it's actually tuned properly. It's yeah, there you go. See you, Will. That was fun. Let's work on this a bit. I missed a message before, didn't I? I don't know if you're still here. What do you think about alpha proof? Very cool. Yeah. Very cool. I don't know what else. The thing is, it's very hard to evaluate how actually good it is. I'd have to ask, like, mathematicians. Okay, let me see if I can get the points clear here, like the story for this. So the intro setup for this is here's AI you know about. It learns one way. Here's AI that learns a whole different way. It was superhuman before LLMs and it has real-world applications, so why haven't you heard of it? Well, it was making waves a few years ago, and then it just stopped. I'm an MIT PhD. I've been working on this for 7 years. I've worked, to make Sims, yada yada, whatever intro I want to do. And this is the RL iceberg. Everything wrong with reinforcement learning and how PufferLib is fixing it. Now, we're not actually going to have this slide, but let me think about the story as it goes from here. The goal is that in the first few minutes after this slide, there should be information that will be new to even current RL PhDs. So there'll be stuff that maybe even current people that are PhDs in RL don't think about, and it just goes up and up from there. It just ramps from there because it focuses on areas of RL that are not necessarily as well known, but are the areas that are causing all the problems. So level 1 is about what points do I want to make here? So here, I want to, the goals are to impress upon viewers how RL and LMs are different, scale differently, and then I want to use that to argue that we haven't been leaning into RL's strengths. So I want to argue that like academic confusion equals RL not leaning into its strengths. Is that a clear point? I want to say that where language models scale with compute, RL scales with data. However, there was this whole period of time in which academia had this neurotic obsession over sample efficiency. So we were trying to get RL to do as much as possible with very small amounts of data. And we have evidence that this is not how RL works. So when you're trying to force RL to do the thing that language models are good at, of course you're going to just go over to language models eventually when it fails. Yeah, I like that narrative. So forcing RL to do what LEMs are good at means you are, of course, going to pivot to LMs when it fails. Get use out of RL. You need lots of data, which since we have GPUs means you need high perf parallel simulation. And that leads us into level 2, which is the infrastructure crisis. How do I want to frame this? Welcome, YouTube folks. Storyboarding out this RL talk that's going to be for the channel, while running experiments in the background and periodically checking on those. Just did a whole bunch of analysis on the MOBA training runs and on some Atari hyperparameter sweeps before. So I like how the intro goes of this. I like how the level 1 narrative is structured. I like the lead into the level 2 narrative. Infrastructure is such a hard topic. How do I structure this? I have here there's so many points I want to make. Black box versus white box. I want to do that. I kind of want to structure, I need to structure this in a way that it is useful for, I'm playing two audiences here, right? This is like, basically anybody in RL should learn from this, whether you're among the best in the world or otherwise. And even if you're not in RL at all, this should be like an entertaining and technically informative video. It's a hard line to stride. I'm trying to be everything for everyone. Doesn't mean I can't make a couple more technical points here and there, as long as they don't go on so long enough that people get bored. How do I want to frame this as a problem? Like, is this a dig at academia? It's not really just a dig at academia, right? It's a huge part of it, but industry has been just as bad with RL. I don't want to make this whole thing a dig at RL lib either. The academic incentives one is a really big part of it, though, isn't it? I could go with the reasons for stuff, which is the incentive structure. I could go with the historical precedent, which is like the story of what happened with Gymnasium Petting Zoo. I could lead one into the other. So something along the lines of, we started off with Gym, which was OpenAI's library for a few of their environments and their really early RL experiments. They did not intend this to become the API for all of reinforcement learning, but that's what happened. They maintained it for a bit, and then eventually it had to be picked up by independent maintainers who had lots of skeletons in the closet to fix. There were lots of breaking version changes that made it very hard to work with different environments that were created in different periods of time. We had the Gymnasium Petting Zoo schism, which caused even more confusion. And then throughout, we have all sorts of wrappers and other critical processes that are living in these libraries that are subtly broken under the hood. I could do a concise version of that. I want to put this in the MISC. This is an important point. But infra has too much in it. So we take the historical perspective. This is a combination of a historical problem and a processes problem, right? The historical problem is that OpenAI, well, they're kind of both at the same time. They're inseparable. I mean, if you think about it, really the whole problem with this is that the stuff that got wildly popular was not designed with the expectation that it would be wildly popular, right? Like, people were writing code for use in their specific paper or their specific projects, and then like the whole community like grabbed it, picked it up, and used it for hundreds of papers without looking for any skeletons in the closet first. Because there's no incentive in academia to look for the skeletons in the closet, right? If there's skeletons in the closet, then those same skeletons have been in the closet for everybody else using the environment, and all you care about is that your algorithm like is in bold font at the bottom and does better regardless of the skeletons. Right? If it's slow for everybody. If you make it faster, you get penalized for making it faster because, if you train for more samples, that's considered unfair. And that ties back into the level 1 thing. Hmm. Okay, so how do I frame this in like 3 lines? At least the intro to it. This is such a hard point to convey because, like, if you haven't worked in reinforcement learning, it's really hard for me to convey just how bad this situation is. 1 second. I do think I forgot a message. Let me reply to one thing, and I will continue thinking through this. Okay. How do I convey how freaking cursed this thing is? Like, what's something that... How can I use the way in which we got to where RL is now? How can I describe that process in a way that makes it clear what a complete mess all this is? Like, this is like everything is broken and nobody is fixing it. I mean, that's like that's the line. That's like the thing I want to convey. Oh, okay. I know how to tie this in. So, because you are interacting with parallel simulations, RL requires a lot of infrastructure not needed in the rest of AI, where you just need PyTorch and a data set. All of this infrastructure came about by accident. A small group even a single PhD student would release a project, and then the rest of the field would pick it up and use it in hundreds of papers. Without checking for skeletons in the closet. Without checking for skeletons in the closet. I need to add this to here, because I don't think I want to talk about academic incentives here. What environments can I say with this? This is not really the best description of what I want to say, right? Because you can't really say if somebody releases, like, ALE Pi was released very intentionally for this, right? Well, not that it was by accident, necessarily. There's definitely the without checking for skeletons in the closet part, though. That's definitely the case. Hmm. I really need... The key with these things that's very hard is I have to be very pithy, right? I have to be very succinct, but I have to be very clear and succinct, and I'm not allowed to oversimplify in the process of doing that. Perf parallel relation is the source all of the problems. Really, if you think about it, everything comes down to the fact that you need high-performance parallel simulations in reinforcement learning, right? That doesn't describe what the problems are and why they exist, but that need, that extra bit, like that extra stack of tooling is why we have problems. And that's not like, oh, let's replace it. No, that's the fundamental core of RL, is that this thing needs to be done well for it to work. GPO just works. Do I put that here? No, I think I put that in MISC. In the rest of AI, you have let's see. When did we get PyTorch? Like 2016? When did PyTorch start getting good? I think it started getting good in like 2016 or 2017. Probably 2016. Getting good in 2016. And the rest of AI, only other thing you needed was a data set which you could load in a few lines of code. Not fully fair either. Bundles, data loaders. I guess this is the key thing is, right, the only tool that you need in the rest of AI to interact with your data is PyTorch and the PyTorch data loaders, right? Data set and autograd. I want to start with this one. Okay. How's that? Level 1, the goal is to impress upon viewers how RL and language models scale differently. There was academic confusion, which meant that RL was not leaning into its strengths. And really, we were forcing reinforcement learning to do what language models are good at, which means, of course, you're going to pivot to language models when you fail to use RL correctly. I can make that story very nice and compelling. Level 2, in the rest of AI, all you need is a dataset and autograd. To get use out of RL, you need Hyperparameter. parallel simulation. And now we can go into the gymnasium schism because it's, yeah. The standard for this is OpenAI Gym, which provides collection of environments and associated tools to run them on multiple processes. But OpenAI let me see. Can I say they didn't intend for this to happen? Toolkit for developing and comparing reinforcement learning algorithms. I don't know if this was changed, though. Oh, this is the original. No, this is really... We need to go back. We need to go way back. We need to go way back to before this was maintained. Oof. It's literally not even here. What happened? I can't... Fuck. I wish we had the original file. Dang. How do we not have that? It's 3 years ago, I guess. It saw 3 years ago, right, on the README. I think that they started maintaining this in like 2019 or something. Or is it? Yeah, 3 years. And when did OpenAI stop doing stuff with this, right? I wish I had the historical context. I can look at Gym 3. Four years ago. So they stopped maintaining this around 2020, right? Oh wait, I can look at the package releases. I know how to do it. Come on, say that this is here. Yes. Okay, good. We have this here. 2019. Fixes slides. Fixes fetch slide environment. So this is not a real update, right? This is the last main update is here in February 2018. Okay. Ah, okay, I see. I know how we do this now. Did people use this as much back in 2018? They didn't, right? Kind of everybody was just doing their own thing back then. Cut release. All M's run off screen. Yeah. What happened since there's 12.5? Were there other versions? Wait. We have to do some archaeology here in order to figure this out. Release history? Ah. There are more packages. What the heck? Why don't we have the commits for them then? What happened? Did they squash the entire frickin' history of this important repo? Who the heck was maintaining this? Hmm. We've lost some of the important history here. That's tough. Well, I mean, I was around this whole time. Were they doing stuff? They didn't really do stuff with this after Dota, right? 2020 is the absolute latest they were doing anything, because that's Gym 3. Seventh, April, October, November, January. Yeah. became the standard more by chance than design, and Jim became the standard more by happenstance than design. Painting project. The 2020 is what we found for sure. In 2020. How many damn releases are there? Would they have tweeted this? I don't even know if I can go back that far. When did they stop really developing it is the question. The ProcGen competition would have been the last thing, right? In 2020. They stopped doing RL in 2020. Meant around 2020. How is this going to make the point? Let me just give it a sentence or two more, and then we'll see if it looks good. Started doing major open source RL development. This is supposed to be stopped. I don't know if I like this narrative, the way that this is going. What happened before 2020? 2020 is already too late. Right? Should have already taken off by then. So what happened? It's the wrappers, the vectorization. What stuff can we say here? Atari being relatively slow. I need to like pin down here. The thing I want to do is pin down like what's like the biggest cause of this. Like I've never really thought about that, to be honest. So this is kind of cool for me. Like what's the biggest cause of infrastructure being on fire? Because if you ask me that, like I can't give you one thing, right? I give you a million different things that are wrong. I can give you like the gymnasium petting zoo schism, like the total mess of versioning, the like poor dependency hygiene, slow wrappers, really poor vectorization implementation, poorly thought out observation and action space API, poorly thought out discrepancy between single and multi agent API, right? Simulation speed. Ultimately, I think ultimately the blame is on Atari. You right? It's on Atari being slow. If Atari were just fast, none of this would have happened, right? DQN's also kind of a slow architecture, but like DQN wouldn't be designed the way it's designed at the moment if Atari were faster, right? Everything kind of stemmed from Atari being slow. That's a funny thing to think about, right? The original DQN didn't even run multiple parallel simulations, right? You see? Wait, state action. Yeah, no, the original DQN didn't even do that was A2C. They didn't do multiprocessing at all, right? I forgot about that. So I guess it's a historical quirk. I don't even know if this thing used GPUs, did it? Probably did. Training and stability. This wasn't even parallel, I'm pretty darn sure. I think it was A2C that was parallel. Yeah. So it's kind of the fact that everybody ran with Atari, even though it became impractical, as is Atari really that Atari's not even that slow though. But we did do the vectorization in Python, in naive Python at that. So I have this in my don't I have this in my paper somewhere? Yeah, I do. How fast did I say it was? Oh, really slow. Really slow. A few thousand FPS. Okay. That's a story. That's a story. Yeah. How much faster? Okay. To get use out of RL, you need high performance parallel simulation. The problem is that this was not recognized early on. DQN paper was everyone used Atari after the DQN paper, which is kind of slow to begin with. Standard wrappers ready with unoptimized Python wrappers and naive, right, and multiprocessing. This limits relation to a few thousand steps per second at most, and left GPUs on 5% utilization. Five percent GPU utilization is pretty bad, and I've seen that many times. Combine this with batch sizes due to an overemphasis sample efficiency, and RL was running over an order of magnitude slower than it should have. GPU flops chart. Where's the freaking chart? $3,000. Okay, we're gonna do something fun here. Flops. Where's flops? RTX. Where are flops? I'm gonna see. What I'm gonna do is I'm gonna show how much you'd have to downgrade your card. It's gonna be fun. Okay, so 80. Is that right? I don't think that's right. There's no way that it goes from 35 to 82, right? Core is garbage. Did they put flops on here? Or did they just put tech porn? Nope. Just tech porn. $35.5 flops. Flops. Okay, so here we have flops. So what I'm going to do here is I'm going to figure out how much slower a card was. NVIDIA 40 series. Transistors, die size. They have flops. Processing power T flops. What's wrong with these freaking charts? Why are they so jank? $40.90, right? TDP. Flops. Single precision, 73. Is that right? That seems really high. That seems like really, really high compared to the previous one. Maybe they got the other one wrong? T-flops. Yeah, that's like crazy. It's like twice the 3090. I don't believe that. Yeah, so this is the thing that they're talking about. Oh, it's a much more expensive card, I remember. Cool. Okay, so we use this number, which is 7382, something like that. So a 1080. So 3 whole generations, 4 generations of cards. It's not even fair because, like, that's so warped. If I were to do from 3090 down to like 3500-ish, 970. No, I think that this conveys it. It's about 4 generations of hardware gap, right? That makes sense. I remember 970s. Yeah, I mean, that totally makes sense, right? We would not have large language models for another 10 years if everybody had to downgrade their chips 4 generations, right? That makes total sense. I think it was more than 10x bad, though. I mean, if I use like default CleanRL or default SB3 as the benchmark, right? It's like 2000. That's like 15x, right? And that's really the fair benchmark. It's like 15x. That'll really drive home the point. So like if I do like 15x, right? This is actually really close to the steps per second of Atari, funny enough. So you go down from here like to 2000 or 2500, right? I think it was like closer to 2500. A 590. That would be the striking comparison, right? GTX 590. This actually might even be being generous, because I've seen worse than this number before, like very often. What number did I quote on the puffer video? Oops. Let me find it. Let me go find the 1500 steps per second. Wait, is this 1500 steps per second? Oh yeah. Okay, here. This is 20. $2,800. And it's 1500 before you use the VEC. Okay. So 2800 is what we're going to go for. That's like the fairest thing. That's based off of my video. $680. A 680. Ugh. Okay. I think that's how you convey it. Okay, I think I figured it out. This is how you convey to people who don't know RL just like how freaking stupid this whole situation is. Why can't I see? Wait. Okay, there. It just didn't rescale properly. When you put speed into perspective, it's like, hey, what if I downgraded your 4090 to a 680? Right? You don't have to know anything about RL for that. You could know that from games, you could know this from other areas of AI. Like you're not getting anything done on a 680, right? You're getting nothing done. I can make this exact point and make it even stronger. Let's just start with that. Like people understand catastrophic hardware failure. They don't understand catastrophic software failure, right? How did I lead the start? What is this talk for? It's not for a conference. It's for the just for the channel and for Puffer in general. I said I was gonna try to make more long form, high quality content. So I'm gonna try this video out, and if like my thesis, if it gets a bunch of views, and if people like it, then I'll make more. If not, then I won't. But this is just getting all of my thoughts out on the current state of reinforcement learning, how Puffer is fixing it, and why this hasn't happened by now. It's very difficult. It's not like, even having worked in this space for so long, like I know all the things wrong, but like conveying these simply is still very, very difficult. It just took me 2 hours to come up with this way of saying it. Like, if I downgraded your RTX 4090 to a 680, you'd understand how bad that is, right? You'd understand that you're not getting anything done. If you train models, you're not really going to be doing that anymore. If you play games, they're not going to look very good. But when you have that same level or worse of efficiency loss on the software side for all of reinforcement learning, nobody bats an eye. And you wonder why this stuff didn't work. Well, maybe your GPU shouldn't be on 5% utilization. How I said that right there is how this has to go into the talk, actually. That's exactly how I have to frame this. What's causing the performance loss in existing implementation? A million things. Catastrophic failure across every single portion of the reinforcement learning stack. There's no other way of saying it. It's not just Python overhead. My whole stack is Python. It's catastrophic failure at every possible point. Garbage vectorization, garbage wrappers, right? Garbage like choices of scaling parameters for GPUs. Every possible point that you make a decision that involves efficiency, we made the wrong one. Every single one. And then to your point, people will go, oh, it's Python slow. What makes vectorization good? Well, look at the PufferLib vectorization. There's a whole thing in the PufferLib paper on archive on how I do it. And for comparison, where is it? For comparison, right? And I made it twice as fast since I released this paper as well. So the Gymnasium Vec caps out at 4.8 thousand steps per second on a high-end desktop. So no matter what you're doing, you're not training faster than this, because this is as fast as you can get new data. With PufferLib, 25,000. And actually nowadays, it's 50 or 60,000. Catastrophic failure. It's actually way worse than this because the way that they would implement training, like they'd get 4.8 thousand steps per second simulation, but then they'd screw it up so bad that training would be at like 2020. I think 2800 was the benchmark that I had last time. 2800 steps per second training. Catastrophic failure. For reference, I'm currently training Atari at about 35,000 steps per second. Right now. On the same hardware. I'm assuming they also vectorize environments. So how's one vectorization better than the other? It's in the paper. I do a lot of stuff. I have nice tricks with shared memory. I have async on policy sampling. I have way better mechanisms of synchronizing workers without introducing inter-process communication overhead. I limit to one environment per. No, I don't limit to one environment per worker, so I don't crowd with lots of small processes. I batch multiple environments per worker, lots and lots of things like this. The puffer vec implementation is, by as far as I'm aware, it's the fastest one out there by a mile. Nobody has the same stuff in it. I didn't realize this when I made it. Tianshou actually had something kind of similar that, like, nobody uses Tianshou that I know, so nobody, like, I think it's more in the branding, right? Chinese, so it's like more popular in China, I think. Um, so they actually kind of had something similar, but they missed like all of the really big optimizations that Puffer has that make it really work. $680 release date 2012. Date 22. It's like 10 years. Am I right that that's a 10-year delay? Double every 2 years? It's not been 2 years for the NVIDIA GPU, has it? 2, 4, 6. That's the number of transistors, not the flops. That's 10 years. What level of programming does this require? Are you implementing custom CUDA kernels? How else do you control shared memory? It's all open source. It's way simpler than you would expect. It's all in Python as well. It's faster than most C++ Vec. Actually, it's faster than all the C++ Vec I tried. Pure Python, not even Python. It's all in here. Timed down to the... optimized to within like maybe 10 microseconds or whatever. We have inter-process communication without signaling via semaphores or pipes or, things like that. It's just signaling is done through shared memory arrays. Shared memory is allocated in one giant block that all the environments write into directly, so you don't have to do data copying on the main process. Asynchronicity. Efficient implementation of asynchronicity. Optional. Useful for most environments. Many, many things. This took me at least a good couple of weeks. It's not that long, though. And there's a lot of stuff in here. Between this and the paper, you'll get the picture of it. Quite a few details. I also discussed this. I have a video on this as well. It's pinned on my... it's on the YouTube as well. It's like one of the main channel videos. So you can see that. Doesn't require implementing custom CUDA kernels because I don't know how to do that. I still made stuff faster, right? That's what I'm saying. It's not like... this doesn't require you to be a total low-level programming wizard. It's just like, yeah, the state of RL is that bad. Hmm. 33. Does the GIL cause any limitations? Kind of. Let me put it this way. It probably would have been substantially easier to implement if I could have used threads instead of processes. But I think that the final solution that I came up with is... I don't know if I could make it any faster given access to threads. Does that make sense? Like making like the current vectorization outside of PufferLib, making the gymnasium implementation faster would be way easier with threads. But I don't think it would be faster than Puffer's implementation. You still incur extra copies and extra bullshit with threads. And I think my signaling mechanism is still probably faster. The one thing is that the one limitation of the puffer thing at the moment is like technically it requires busy waiting in one spot. There's one spot that you have to do busy waiting, which is kind of awkward, but it makes a huge performance difference. You might be able to cut that out with threads, but you might not. It depends on what signaling mechanisms would be available. And of course, even if you had no GIL threads in Python, that doesn't mean that they're going to be fast. I mean, we're looking at like individual microseconds that you can shave off potentially here. Um, because you need to have, if you want to have million step per second vectorization, right? If you want to have stuff that scales like that, well, if you have a microsecond of overhead, then you're not getting a million steps from one process. Now, we're not getting that anyways, but, across all the processes, we definitely are. Let me see how I like this bit. What does 900% overhead look like? That's like downgrading your RTX 4090 to a 680, or waiting until 2033 to be able to train GPT-4. Welcome to reinforcement learning. After the DQN paper, RL research standardized on Atari, which is slow to begin with. Tack on a bunch of unoptimized Python wrappers and naive multiprocessing, and your simulations are limited to a few thousand steps per second at most. That's good framing. That's a good, like, overview, I think. Slightly longer than the first one, but this is the longest section of the talk, the second section. I like that. I like that. This is the hard bit. The framing is the hard bit. The content is the easy bit, right? The framing of the story and the getting like the main points right is the really really hard bit, right? Doing a slide on like, you know, what's wrong with observation and action spaces, how does Puffer fix that? The technical stuff is easy. Framing stuff is hard. It's kind of funny. It's kind of like how coming up with good abstractions in programming is hard, and it's so hard to the point that like the right thing to do is almost always to just not come up with abstractions and just write all the code as simply as possible. But you can't do that with this type of content with storytelling because you need to have those like clear signposted messages right at every step. Because if listening to a presentation or listening to a talk is like reading 1,500 lines of code, well, that's not going to be a good time, right? Like every single time I think it's going to be cool to like go through the entire implementation of a thing, right? And just like show you block by block how simple it is and like how nice it is. It never works in a presentation, right? Because it doesn't follow like the narrative arc that people expect. It's weird. Okay, so the third section is about how all of reinforcement learning is wrong. Um, I mean, I think I can make this point without even getting into academic fraud. I've seen plenty of academic fraud in my day, and plenty of like, you know, unintentional or like, you know, swept under the rug. Probably we should have evaluated this thing better. That's very common. Heck, we found something today in one of the most cited papers out there. Let me go through. I see we have a bunch of folks on YouTube who like watching me make slides for some reason. Welcome. I do actually do experiments as well. We have some training in the background. Lots of experiments training in the background, actually. Here's 264 of them. And then on the MOBA, let's see if we've gotten any progress. 36. A little bit. Interesting how this shape works out. We'll have to look at that later. But yeah, we got stuff tuning on both. I'm going to go through this one more time just to see if I like the narrative of it. And then what I'm going to do is I'm going to go make myself a shake, be back after 5 minutes, and then I'm going to do level 3 of this, the MISC, and then hopefully that'll give me... I'll probably have like an hour or two to actually start on like the individual, like the more specific content. I don't have a release date for this talk. It's done when it's done. So the story here is going to be the flow of it. This isn't the actual content, but the flow is along the lines of, here are language models. This is AI you know about. It learns one way, by compressing text. Here's AI that learns a whole different way. It was superhuman before LLMs even existed, and it has real-world applications. So why haven't you heard of it? Well, reinforcement learning was making waves a few years ago, and then it just stopped. I'm Joseph. I'm an MIT PhD. I've worked in reinforcement learning for 7 years. I created Neural MMO, and this is the RL iceberg. Everything wrong with reinforcement learning and how PufferLib is fixing it. This will not be included as a slide. This is the outline of what I want the presentation to be. Level 1, the goal is to impress upon the viewers how reinforcement learning and language models scale differently. Reinforcement learning scales with data. Language models scale with compute. Academic confusion meant that really we spent a lot of years in reinforcement learning research not leaning into the strengths of reinforcement learning and instead demanding that RL work like an LLM and that it scale with compute instead of data. So forcing RL to do what LLMs are good at means, of course, it's not going to work and you're going to pivot to LLMs when it fails. Level 2 is about the rampant inefficiency and difficulty of working with infrastructure in this space. What does 900% overhead look like? That's like downgrading your RTX 4090 to a 680 or waiting until 2033 to be able to train GPT-4. This is reinforcement learning. So after the DQM paper put RL onto the board, research standardized on Atari. Atari is already slow to begin with, but when you tack on a bunch of unoptimized Python wrappers and really naive multiprocessing implementations, your simulations get limited to a few thousand steps per second at most. For comparison, Puffer's new sims run at 1 to 15 million steps per second per core. More on that in a bit. For now, let's talk about how we got into this mess and how PufferLib is fixing it. And the agenda for that is going to be the gym and gymnasium petting zoo schism, slow wrappers, Mikado paper that I just learned about today was being wrong. We're going to talk about complex observation and action spaces and how those are difficult and inefficient to work with. We're going to talk about simulation techniques and all the stupidly slow simulators that have been released, and vectorization and how you have to put some work into that to make that fast. How does meta RL? I'll take this question and then get my shake. So I'll be back at 5 minutes after I answer this. How does meta RL get optimized? You cannot have any mini batches, and the gradients seemingly blow up with large batches. How does meta reinforcement learning get optimized? You cannot have any mini batches. I don't think that that is strictly true. So first of all, there's not a consistent framing of meta learning in the first place, right? If you're talking about, what's it called? MAML? No. What's the acronym? Is it MAML? Whatever, the really obnoxious one where you do gradients of gradients. Yeah, that one's kind of jank. There's also, there are like architecture implementations of this as well. There's like Snail, there's like the classic continual learning framing, right? The Schmidt-Huber-esque one where you just don't reset LSTM state and you learn across episodes that way. Yeah. So I don't think that like that one, I didn't even really like that approach to doing it in the first place, is what I would say. Learning to learn. First of all, you don't even necessarily have to train, sampling new on policy data. Yeah, the thing is, like, that framework there, that's not even necessarily the way to go, right? Like, new on policy, so you can't, I don't, just because mammal's jank doesn't mean that meta learning is ultimately going to be bad. There's a question of whether you even need to do explicit meta learning in the first place, right? The idea is that you want something that can learn to learn. That's the whole concept, right? RL has this really bad habit of splitting out like individual aspects of learning and then making them into subfields with an explicit objective before we know that that problem even needs to be answered. Let me give you an example. There's a whole bunch of research on algorithms for theory of mind. but we know that theory of mind can be learned implicitly by simple on-policy learning, because the Dota bots doing what they did requires that they have a modeling of what the opponents are doing. Same thing with the StarCraft one. And they don't have explicit theory of mind work. It's just emergent. Same exact thing could be for learning to learn, right? For curiosity, entirely possible. Same exact thing could be happening for world models, right? We might not need an explicit world modeling objective. You need to have some sort of internal world model, implicit or explicit, in order to reason in complex environments in the first place. So it could very well be that meta learning happens just by training on a bunch of environments at the same time once we get a sufficient number of high quality, fast environments. It could be that we do something way simpler where we come up with, like, a better way to have explicit memory, and that's the thing that gets updated over, multiple episodes or something. There are many, many ways that we could implement it, and generally, I would say that we should lean into algorithmic approaches that scale with hardware. So if we're looking for things that are likely to produce good results in learning to learn or whatnot, we should look towards algorithms that are easy to scale with more GPUs and with faster simulations, right? We should not be trying to put ourselves into a box of doing stuff that scales poorly with hardware advancements. Betting against hardware is a bad idea. So having jank algorithms that make it really hard to scale or make it really hard to implement efficiently, that's probably the wrong way to go. That's my long-winded answer. I'll be right back. I'll be back in like 5 minutes. I'm going to make myself a shake, and then we're going to do, I'll answer a couple questions with this maybe. We'll do level 3. I'll do maybe a little bit of the MISC outline, and then I will start on individual slides. That's what I'm going to do. And we'll check maybe some experiments. Be right back. Okay. I am back. Hello, folks. So funny to me that people actually like watch me making slides and stuff. I've noticed like viewership tends to go up when I have like a new cool code thing that I'm doing that like can teach you some particular info or whatever. Or like when I'm doing something like this interactive where I'm like talking through stuff. And then obviously when I'm doing like the deep work on code, then people get bored. It's funny. Anything exploding here? Oops. Nope. Cool. So, level 3. How do we prove that all the science is wrong? Impossible that the majority of reinforcement learning papers are good science. I gotta go reread the statistical precipice papers because I think that I have a slightly different argument. Actually, let's pull that paper up real quick just so I refresh a little bit. So this paper, everybody goes nuts about this paper. It's a Belmare paper. Wait, wasn't he on the frickin' Mikado paper? Wait. This is a Belmare paper. This is a Belmare first or second author paper. Okay. Hold on. Comparing their relative performance on a large suite of tasks. Most published results compare point estimates of aggregate performance, such as a mean and median score, ignoring the statistical uncertainty implied by using a finite number of training runs. Beginning with the arcade learning environment, the shift towards computationally demanding benchmarks has led to the practice of evaluating only a small number of runs per task, exacerbating the statistical uncertainty in point estimates. In this paper, we argue that reliable evaluation in few runs deep RL regime cannot ignore the uncertainty in results without running the risk of slowing down progress in the field. We illustrate this point using Atari 100K, find substantial discrepancies between conclusions drawn from point estimates alone. It's more thorough statistical analysis. The aim of increasing the field's confidence in reported results with a handful of runs, we advocate reporting interval estimates of aggregate performance and propose performance profiles to account for the variable results, as well as to present more robust and efficient aggregate metrics such as quantile mean scores. We scrutinize results of existing algorithms, including ALE, ProcGen, DMC, revealing discrepancies in prior comparisons. We prevent an open source are reliable to prevent unreliable results from stagnating the field. Everyone, yeah, this is what I remember it being. Everybody went nuts over this paper, and I always thought this paper was stupid. You know why I thought this paper was stupid? Because it's like you're a Google Brain researcher where you have a bunch of compute, and you're basically saying that we need to run more random seeds for all the environments. And like this stupid benchmark is already so slow that it's impossible to do that. So like the solution to this is not like, oh, you guys need to do better science. It's we need a faster benchmark so that we can do that. This is such an academia paper right here. This is peak academia here. Atari 100K is a stupid benchmark as well. Stratified bootstrap. Confident. So what you're recommending is you just report a massive confidence interval that's useless because you can't. Yeah, I remember this is why I hate this paper. I gotta reread the full paper to be sure. It's funny I found two papers by the same guy who's like incredibly well known that I hate in the same day. This is like such a you're technically correct, the best kind of correct paper, right? I had to reread the whole paper before I say I totally hate it, but I mean the framing of this thing is awful. It's like a paper about the problem, completely ignoring the cause, which is that the environments are too damn slow. Okay, so now I know I don't have to care about this here. I'm going to address this paper here, actually, because this is a very widely known and respected paper. How should I frame it? Ported. Computed using, what is this? Yeah. Most published results are too noisy. Used basis. Pause this problem. can't run more trials. Researchers can't run more trials because environments are so slow, they barely have compute. Let me see. Can I see how much compute they used in this paper? That would be hilarious. Uniformly sampled with 100 runs. Case study on Atari 100K as a dumb benchmark. Statistically impossible. Is this how I want to frame this? Let me work this all the way through, and then I'll see if I can cut it down. Oh, I know what I can do. One of my recent works. We ran a simple ablation study on Atari for a single for how many tricks did we test? Tricks on NeurIPS. Yeah, this is bad. That's so funny. Where's our paper? NeurIPS 2023 Dreamer B3 Costa Huang, Suarez, and Ryan. Yeah, here it is. So, how many tricks did we test? 1, 2, 3, 4, 5. We tested 5 tricks. Simple tricks. Algorithmic modifications. None of which increase training time. to get reasonable how many seeds did we do? Multiple seeds. Three seeds. Get results for 3 seeds. Spent 10,000 A100 compute hours. This was through a partnership and would be out of reach of nearly all academics. The precipice, at least 25 seeds. Let's academics do not have enough hardware to do this. Is impossible. That majority of published papers are statistically sound. Okay, this is the argument. I think this phrasing is really bad and really like over long-winded. Let me go through this. Because this is like it's so funny that like all throughout my PhD, right? I kept getting told like, oh, this is engineering, this isn't science. You're just doing engineering, you're doing performance optimization, you're not doing science, right? This is what the crusty academics will tell you. But here you can see provably that whatever you're doing, it ain't good science. Because I know you don't have the hardware to do this properly. Because your environments are too slow. And the funny thing is if I just made all your environments 100 times faster, you could do good science. You do the exact same thing that you're doing now, do more runs, and you'd have good science. Perfect. So doesn't that make engineering science? Doesn't that make engineering good science? If you literally can't do good science without it? I've had academics tell me like, yeah, it's needed, but then the engineering itself still isn't science. Isn't that crazy? Like, yeah, we need the engineering to do good science, but the engineering itself isn't science, so that shouldn't be published. Isn't that funny? It's like, yeah, we just expect somebody else to do all this for us and for free. And then what we're going to do is we're going to make sure that you can't even publish your work. We're going to make sure we reject all your work through a review. And we're going to just expect it to get done anyways. That's the real state of things. Let's go through this. It is statistically impossible that the majority of RL papers are good science. The well-known statistical precipice paper shows that most published results are too noisy to tell when one method is better than another. I don't like this paper. It's technically correct. The best kind of correct. I don't need that joke in the intro. But it completely ignores the cause of this problem. Researchers can't run more trials because the environments are so slow. They barely have compute for their current work. In one of my recent works, we ran a simple ablation study on Atari for 5 simple algorithmic modifications, none of which increased training time. To get results for 3 seeds, we spent 10,800 compute hours. This was through a partnership and would be out of reach of nearly all academics. The Precipice paper suggests that at least 25 seeds. Since academics do not have enough hardware to do this, it's impossible that the majority of papers are statistically sound. It's a sound argument, but it doesn't win. You don't win just by having a sound argument. You need to have a pithy argument at the same time, right? So, I mean, the format for this is like catchy some sort of hook, provocative hook that then is explained. Catchy hook. How do I want to hook this? The only correct RL papers are from Google. Where's Mark Bellman? Is it Mark? Is it this guy? Wait. No, is it this guy? Wait, Mark Belmare. No, wait, where's the frick? Where's this paper? Mark. Is it this guy? Wait. Is this The Economist? Wait. This doesn't seem right. If it's this guy, I'm gonna understand. Well, his website doesn't work. It can't be this guy, right? It's this guy. Reliant AI. Oh, he's doing some weird thing. Okay. Um. So he's not a prof. Okay. And he was at Google, right? Yeah. Research lead at Google Brain. DeepMind. Okay. Only good reinforcement learning papers from Google. That's kind of quippy. I like that. Is it all Google? First authors Google, Google, Google. Yeah. I'd say Google. Statistical precipice paper demonstrates that RL researchers don't or hardly ever run enough experiments to statistically prove that their methods are good. I'm trying to do like a quippy thing here where I'm essentially saying that Google wrote a paper saying that we have a lot of GPUs, right? Because that's what this ultimately amounts to. Like, they wrote this really long-winded statistical paper that ultimately says, hey, you guys can't do RL because you don't have enough GPUs to do it right. That's ultimately what it says, right? I gotta figure out how to get the language on this right. The framing of this is very important. Because this genuinely isn't RL researchers' fault, except insofar as it blocking blocking systems research from being published. That's the only thing that's really the RL community's fault. And a lot of that's more senior people, like ACs. I think I saved this as the quip, and I do. Almost all RL papers are wrong. Very few publications contain enough experiments to statistically back their claims. Is technically correct, but misses the point. It's a Google paper arguing that only Google has enough GPUs to do RL right. To do RL right. Researchers can't run enough experiments because Atari is too slow, and you need Atari results to publish. Okay. I think we're going to split the second part out into more slides. But I think that this is like a more like... Because this like... This is the thing that I want, right? This draws the parallel between fixing the science of RL and just improving the infrastructure. This is how just improving the infrastructure makes the science of RL work. Right? The environments are fast, you can run more experiments. It's that easy. You don't have statistical evidence for your claims, run 10 times more experiments. Now you have your evidence, right? If you run 30 seeds instead of 3, you're good. I really like that interpretation. Google argues that only Google has GPUs to do RL right. I like that. This is rapid fire weigh in on a bunch of topics that didn't fit anywhere else. JAX is domain-specific languages. Limit the sims we can write. And hold RL back from working on more interesting M's. It's good for physics, a life, and a few other niches. CraftX is the exception that proves the rule. Academic incentives. Academia revolves heavily around math, algorithms, the narrow definition of science. If you write an algorithm that does 10% better than current state of the art with mediocre statistical evidence and experiments, that's a good paper. If you write a tool makes all algorithms 10% faster, you get nothing. Get a NeurIPS spotlight. If you write a tool that makes all algorithms 10% faster, you get nothing. No wonder none of this has been fixed in 10 years. Okay, I'll have to make that point better, but it's absolutely true. What about industry? Too many FANG engineers used to big software. Industry libraries try to modularize RL into a bunch of neat little black boxes that always work. RL is an emerging field, and researchers need to edit every portion of the stack, meaning it needs to not be 30,000 lines. PufferLib follows clean RL's white box software approach, meaning all the code is as concise, simple as possible, with minimal abstractions. So you can't use it to do as many things off the shelf, but it's easy to edit, understand, and edit. Okay. Open-endedness. The thing about this is that nothing has been conclusively better than PPO, which was published in 2017. 2017, right? Yeah. And solved DOTA with a 160 mil RAM neural net with a 1-layer LSTM. Okay, and I make that point somewhere. Open-endedness. I weigh in on lots of subfields and thoughts about them. Open-endedness, AI that keeps learning forever. Cool concept. Requires more complex and performant sims than we have bothered to develop. Likely an area that will be propelled by high performance engineering first and algorithms second. Meta learning, learning to learn, similar in concept, more related to generalization, to new environments or tasks. You don't get something that learns the general process of learning by only playing Pong. Again, requires complex and performant sims. In the meanwhile, curriculum learning, practical alternative, curriculum learning that can do many tasks or that is trained on many tasks to better perform a single hard task. It's a more immediately achievable goal with real success that has seen real success. Still requires good sims, but more feasible than open-endedness or meta as a short-term goal. Curiosity. Slash continual related continual learning. Continual curiosity. Involve learning to learn. Okay. And what else? Loop. Otherwise, you get the compute demands of LLMs, the data demands of RL. Likely want to query like 0.001% of the time to guide RL or use LLMs to set tasks for curriculum learning. Okay. Those are some good thoughts. It's a pretty good outline. I think I get to start working on the actual slides now. I don't know if I want to. It's so annoying. Like, as soon as you go down to the level of granularity of like slides, you lose all the higher level stuff, and you're just like, you just start thinking about like the placement of text and stuff like that. I think I want to figure out maybe a little bit more granular first, like how many slides I'm going to do and what they're going to look like. Or maybe I just do some intentionally really crappy slides. Maybe that's better. So like if I make them intentionally bad, then I won't be, I won't spend the time to fine-tune stuff until I have like the full outline that I'm happy with. Because prematurely optimizing this is It's the same as in code, right? Let me double check a thing or two real quick. It's 5:12, meaning I'll probably be doing this for another hour and a half-ish. Cool, got a thing confirmed for tomorrow. This is funny. I think I told one of my collaborators to use Twitter because it's needed. You need to use Twitter and AI for anybody to know anything about your work. And he started tweeting like, frustrated things about the PufferLib config system. And it's, like, hey, okay, you can use Twitter, but you know that I read it too, right? You all should follow Kyung, by the way, if you use Twitter. He was really the major force behind the latest Neural MMO competition. He has done a ton of great work, and he's just come back and started using Twitter. So, expecting to see great things from him soon. And since we still have a few people on YouTube, in case we have anybody new that hasn't seen this before, oops, not this. All the stuff that I work on is open source on GitHub. If you want to start the repo, pufferai/pufferlib, it helps me out a whole ton to get this stuff out there. I know right now I'm just working on this like video/talk thing, kind of framing what Puffer's doing. I think that's going to be important. But most of the time I'm doing experiments and deving stuff. I've got these running in the background. Let's do a quick checkup on them. MOBA found a few good settings. I don't know what it's doing now. What is it doing now, actually? Oh, it's doing shorter runs, it looks like, for the most part. Yeah, so what it's doing right now is it's doing a bunch of shorter runs. It's looking for a set of hyperparameters that's better than the really long set of hyperparameters. So that's actually very reasonable for it to be doing. So it's going to spend a whole bunch of time looking to see if it can find something better than these long ones here. Which is kind of funny that it does that. How about our Pong sweep? Oof. Well, we got Pong solved. So I'm definitely going to kill this and then rerun it before I go today, because we have to run the alternative version of this. But this is a very nice result. I guess it's going to just try to solve it faster and faster now, right? Episode return. Let's see uptime. So 300 is 5 minutes. So the best we have right now is 18.6 in 4 minutes, it looks like. 18.6 in about 4 minutes. Or, yeah, these ones all take longer, it looks like. This is the Pareto Optimal Frontier. It's pretty good, though. 18.6. Very nice graphs. Okay. Let's start on some slides. So impress upon viewers how RL and language models scale differently. Okay. Academic confusion equals RL not leaning into its strengths. So let's do let's see, debacle. Saying round pegs into square holes. Square pegs. Okay. Okay. RL scales, or was it LMs, scale with compute. RL scales with data. Oops. Scaling laws. Where is it? Where's the thing? Yeah, this is it. Isn't it? So we just grab this. Let's prove this. Scaling laws prove this. Okay. So essentially, these two are fundamentally different, and we actually have proof that this is the case. We have proof. You need 100x less compute at most, or RL. Okay? Which means you spend the balance on more data. It's in researchers want it to look like this. Image. Because real world sample CNC. Robots are not the only use for RL. Round pegs, square holes. Lots of simulators and interactive online processes. Round pegs, square holes. Okay. And then I have to show how bad this is, right? I have a slide for this. Yeah, this was a good slide. Lots of data. We do 200 mil from 10, and this goes to 1.4 TB, right? 1400 gigabytes. And then you always do you always do it like this. $60K images. Does this make sense? Times 0.8, 6. Yeah, that's perfect. Like 47 MB. I was making sure I got the data calc right. Doing back of envelope data size calcs is really useful. Only have 46 MB of data. Train old digit classifiers. But in RLs, we train on over 1 terabyte data and have unlimited more where that came from. Round pegs, square holes. I like this. This is funny. This section is too short relative to the other ones. Let me think, how can I... This section is just way too short. Oh, I know what I should do here. I should link this to PufferLib somehow, right? I don't know. I'll just grab a random sweep for now, because that's probably what we're going to put on here is like a sweep graph. And probably just put a sweep graph on here, right? Whatever, I don't even need a placeholder. We do sweep. PufferLib designed to play to RL's strengths. That's not entirely true though, right? And for high data things first, and trickle down results to lower data settings. Apply insights from scale to lower data. That's better. I like that. Okay, 1, 2, 3, 4, 5. This is like a nice intro section. It's pretty easy to digest, right? It tells you something nice and high level about RL. Language model scale. And I like that having this first section being more accessible as well. Language model scale with compute. Reinforcement learning scales with data. We have proof that you need 100 times less compute at most for reinforcement learning, which means that you're going to spend the balance on having more data. As a comparison, you only have 46 megabytes of data for training old digit classifiers, but in reinforcement learning, we train on over a terabyte of data and have unlimited more where that came from. For some reason, a lot of researchers want RL to look like this because of real-world sample efficiency. They want to apply reinforcement learning to low data settings. But this is not playing to RL strengths. This is hammering square pegs into round holes. And maybe RL will be able to do this eventually, but it's a heck of a lot easier in an emerging field to play to RL strengths first. Something like that. Our PufferLib is designed to play to RL strengths. We design for high data settings first, and then apply the insights from scale to lower data settings after. That's a good slide. I mean, a good, like, good rough narrative. I think that the arc of that is good, and I can polish it from there. Level 2, infra on file, on fire. Infra on fire. I don't even know what to, like, attribute this to. Oh, actually, I know what these headers should be. The sample efficiency debacle. Round pegs into square holes. That's a nice little motto there. Infra on fire. A tale of 900% overhead. That's good. Didn't I have I thought I had this graphic somewhere, didn't I? Yeah, this one. Does work? It's obnoxious. Does this do background remove quick? What's the frickin' dingboard background thing? Damn Axion. Oh my gosh. Frickin' internet these days. Oh, this was good. If I can get the image. 680. There we go. Okay, we'll think of a graphic for this. Let's grab some GIF. Okay. We do some GIFs. Now we got to do the observation action spaces thing. I'm sure I've done this slide somewhere. Uh, 2D map. One D array. Scalar. This thing is flagging the heck out of slides, isn't it? Yeah, this GIF is too big. So you can't give Google Slides GIFs that are too big, apparently. It's so obnoxious that you can't give it like anything. This. There you go. You can use this. Okay, so we get compatible observations and actions. We'll have a slide on that. Fast simulation. Fast simulation. And then vectorization. I think we get like a good mix of different types of data, right? We do like from the paper here. Covers our bases. Okay. Fast vectorization. Oh, and then we'll put the link to my talk on that, right? Okay. This is going well. This is going fairly well. I mean, these are like really bad slides, but you know, we don't care about that. We care about the getting the high level right now. If I can get like the high level of this whole talk kind of sketched out at least somewhat decently today, I'll be very happy. And then we do all the sciences wrong, which is the fun one. Oh, there was something outside and I was just very confused. Okay. First are almost all wrong. All the science is wrong. Science is wrong. Google can do good RL. And GPU. Something like that. All the science is wrong. So the things we need to cover here. Too slow. Well, we would need to start with the statistical precipice paper, right? Can't do science. Not this one. Is there no like, whatever, we'll do this. We'll do it this way for now. These are not final figures. I'm intentionally doing this quick and dirty so I have to redo everything so I don't get stuck on anything. We'll put in at least a couple fun memes with this, though we'll keep it mostly pretty serious. Where's our paper? Yeah, this is actually such a good paper. Not because of the contents of it, but because of like what we found out about how freaking screwy it is to try to do any science in this field. Like if you actually try to do the science correctly, what a pain in the ass it is. These seeds. Okay. Science section should start with 2 papers. That makes sense. And then let's do a sweep. We're going to do like a sweep graphic here, right? This is what this is what science looks like right here. Parameter sweeps on one GPU. Bad assumptions about single sets of hyperparameter. Do I want to cover that? I think the sciencey section can have more papers as figures. Where's this? They have a nice figure I can steal. They have an archive paper, don't you? Yeah. They have an archive paper here. I can tell every time I open an archive paper, the viewership drops by half. So I can't put too many of these in. Otherwise, nobody will watch the talk. White papers are boring. I don't know when the last time is I've read a full white paper. I get bored and fall asleep. I think I've fallen asleep writing my own white papers. No more of those. Waste of time. Instability of eval results on classic benchmarks. Do we have any cool figures in here? These are kind of nice. Do we have a figure that was showing how freaking noisy this was? Ryan and Costa did really good work with these figures. These are very clean figures. Okay. Did I miss a slide earlier? On like wrappers? I thought I did. Yeah, infra on fire. Gymnasium, puffer. Do what's the other one? Stable base times 3. I don't know why this is the logo. This is so funny that they have this as the logo. The heck? Oh. I should probably explain where some of this comes from. But we'll have to do that after. Okay. The important thing is I have a placeholder for the slide. So that I remember for the narrative. I know, like, the rough pacing. I want this slide, right? Looks better. And oh, I need to do the MISC section, right? Yeah, MISC section. Okay. Use DSLs. Don't overuse DSLs here. And we have academic incentives. Let me think. I could put that letter I did, right? Where the heck did I do this? I probably did it on Puffer. Let me go grab that real quick, 1 sec. This was actually a kind of a cool thing I did. I don't really think I'm going to be doing much of this more anymore, but let me go grab the title page. So I wrote this open letter to NeurIPS DNB, and I actually got the call for papers changed as a result of this to be more favorable to infra-N libraries. I need something, but I need a better image for this, but get some, some extra stuff in there. Black box versus white box, that's easy. I'm just going to take this for now so that I know I put an image about black box versus white box. Essentially, the goal is to get this whole thing flow through with everything so that I know when I actually go to spend the time to make all the graphics and make everything look good. The goal is to spend no time making graphics that I don't end up using. We're going to do the PPO architecture. Works. We'll have to annotate this up. Meta learning, curiosity. Let's do like this. Meta learning, curiosity. Learning. open-endedness. Then we'll do like something like this for now. Whoops. Okay. Whoops. What the heck? You literally can't even see this stuff. Okay. Cool. We're at about 30 slides in the deck. About 30 slides in the deck. What time is it? 6:05. It's not bad. Not bad at all. How much more do I want to do today? I'm going to go use the restroom. I'll be back in a minute, and then I think I'm going to try to like go through this. I mean, this is not like rehearsing the actual... What I do when I do presentations a lot of the time is I go through it a whole bunch of times, just like absolutely terribly. Like if I gave this presentation like this way, it would be terrible. But I go through in a way that helps me figure out the structure of stuff. So I think I'm going to do that a little bit. I'm going to go through a bunch of the slides like out loud and figure out the structure. So I'll do that when I'm back. And then we'll, before I end the stream, hopefully I remember. If not, hopefully somebody reminds me to relaunch the Pong sweep. And I'll explain what we're doing with that. That's kind of nice. All right. Is there an optimum video length for YouTube? Is there an optimal length? I wonder if there's data on that. If I like have anything to shoot for. YouTube video length. I think it doesn't matter. I don't think there's a way to game it. I think it's just make good content, which is better anyways. Okay, let me see if I can get like a rough estimate of how long I think this is going to take though at the same time. You've heard of ChatGPT. Language models learn by compressing text into tens or hundreds of billions of weights. But there's AI that learns a whole different way. Reinforcement learning learns through interaction with simulations. It was superhuman before large language models existed and has real-world applications. So why haven't you heard of it? Well, it was making waves a few years ago, and then it just stopped. I'm Joseph Suarez. I am a PhD from MIT. I've been working in reinforcement learning for 7 years. And this is the RL iceberg. Everything wrong with reinforcement learning and how PufferLib is fixing it. How do I want to section this? So like a minute or less for this opening section, I think is the idea. I want to get to the title within like ideally 30 seconds. So even though there's 6 slides here, this is like 30 seconds of content. It's the most important 30 seconds of content in the video, but it's 30 seconds of content. I might do some cool transition as well with like, I might do a little bit of light video editing to have like the chapter slides, come up on their own. Something. Part 1. The sample efficiency debacle. Language models and reinforcement learning are fundamentally different. Language models scale with compute. Reinforcement learning scales with data. We know this from research. We have proof that you need 100 times less compute for reinforcement learning, which means that you need to spend all that extra time on data, something like that. Let me give you a comparison. With this old task of training a handwritten digit classifier, you only got 46 megabytes of data. But in reinforcement learning, also for very simple tasks, we train on over a terabyte of data, and we have unlimited more where that came from, because we can just run the game for longer. But for some reason, researchers want it to look like this, because this is an uninterpretable point to people. For some reason, researchers want it to look like this. They want reinforcement learning to learn with a lot less data, or another way, a lot more compute per piece of data. A lot of this comes from robotics, because in robotics, you only have so much data because you have to run the robot in the real world. You can't run it any faster than real time. But that's not the only use for RL. There are lots of simulators and other interactive online processes for which you have unlimited data. And this is where reinforcement learning really shines. So trying to make RL behave only in this way is hammering round pegs into square holes. I don't like that slide. PufferLib is designed to play to reinforcement learning strengths. We design for high data settings first and then apply insights from scale to other lower data settings after. So I think this section just makes no fucking sense the way that I have it right now. This makes no sense whatsoever. I'm trying to make it too fast. No, it's not that I'm trying to make it too fast. It can be fast. But I need to get the points. The points need to be very pithy if I'm going to do it like this short. I think what we do is we do like this. We do like this. Then we put this here. And like this. Dota 2. Wait, what the heck is this? I'm confused. Hold on. Where's the paper? Single agent scaling laws? This paper. Right? Optimal model size versus compute. Procgen width. So wait, this is saying the heck is up with the Dota 1v1? Their model was bigger than this, wasn't it? Oh, this because the petaflop days is pretty short. $100 to 1000x. What's this mean? Am I reading this correctly? Whose paper is this as well? And Schulman paper, okay. Coefficient, not the exponent of this relationship. Oh yeah, because this MNIST thing was like an RL. Yeah, they did something weird with this, I forgot. Reinforcement learning problems need models 100x smaller. 1 or 1% of the size of, let's see, LM scale with compute, LM scale with data. Now that doesn't make sense. It's parameters. Way more data. Something like that. Okay, so this is, I'm sure I can get this point to be clear from here. Language models need lots of parameters. RL needs lots of data, which means for any amount of compute that you're going to spend, reinforcement learning, you're going to spend way more of it on data. This matches what we would want. It just so happens that this is the way we would want it. For language and vision models, we only have so much data because it comes from the real world. For this MNIST data set, this old task, we only had 60,000 images, 46 megabytes of data. For this relatively simple reinforcement learning task of breakout, we would train this on 200 million images, which is over a terabyte of data, and we have unlimited more data where that comes from because we can just run the game for longer. Okay, I think that this narrative for these two is good, and then it falls apart here. There's constrain. Maybe give some intuition. No one expects humans to master Atari in 10 minutes, but rather through extensive experience. It's a bad analogy is the thing, because reinforcement learning needs way more data. The thing is that yes, I could give it, but it requires an extended chain of logic, that's like already going to lose people. So the actual reason for this is that, right, reinforcement learning is way less sample efficient than humans. It needs to be trained on way, way, way more data because reinforcement learning is tabula rasa, where humans are not. That is, reinforcement learning is a blank slate. It's learning without priors. Humans have tons of priors, right? They already know how to play the game without ever having played it, more or less, because they understand visually what everything is supposed to mean. They understand that they can press a button, it'll go right, it'll go left, right. They immediately have the priors to do that. Um, Case in point, like GPT being able to play some simple games, it's not learning any of that in real time, right? It just knows how to do that from having seen similar problems. So, for that reason, it's not comparable. But the goal of reinforcement learning is not necessarily to learn as fast as humans, right? It's to suck up as much data as possible for the wide number of problems in which we have unlimited data. Because if we have unlimited data and we have a method that's really good at using unlimited data to learn very, very high quality policies, well, that's just perfect, right? So the problem comes when researchers want to constrain reinforcement learning to have to be very, very sample efficient and then expect it to do something. And then, progress gets stalled out because that's not what reinforcement learning is good at and the results don't look all that impressive. And then they move on to language models. That's kind of what happened. 100,000 frames. Work in low. anybody done this? Nope. Oh, come on. Freaking real therapy. Get out of my recommendations. Screw you, Google algorithm. What game is this? What? Well, yeah, if you put it like that. Yeah. Yeah, not even close. Okay. I was just wondering if anybody had done this. Huh. Yo, what's poppin'? Trying to make this talk while watching experiments in the background. Going through all the stuff wrong with reinforcement learning and what Puffer's doing about it. It's an interesting talk. I'm trying to make this something that top reinforcement learning researchers will learn from, but also will be entertaining and informative to people who are like brand new to AI and RL. How are experiments going, speaking of which? I don't know why. Actually, I do know what's happening here. I think it's actually kind of good what it's doing. Let me see. So this is our like mini Dota model. And it's showing 100 runs. Okay. And if I look at like... Yeah, so it's doing a lot of short runs. Okay, so what's happening here? I think I figured it out. So the reason that you get this like quick uptick, right, with carbs, and then later, it takes forever after that. What's MOBA? It's like miniature Dota, Defense of the Ancients, League of Legends. Where do we have one? Where's the GIF for this? I have a bunch of them on Twitter. What happened to me with carbs? Yeah. But I think it's a feature, not a bug. Let me find the thing. Okay, yeah, here's our miniature MOBA. Right? You have characters, you've got heroes, you've got waves, you've got enemies. It looks like a MOBA at a high level. And we're doing reinforcement learning on it. It was sticking to the lower end of the total time step range because of the uptime cost. I think what carbs does is, and I saw this with Pong as well, you have to run it for quite a while, and we might have to change the settings for this. I might ask them. I might ask the devs of this. So it did some long runs up front. So these are like really long runs, right? And then it says, okay, I know how to get high reward. Can I figure out how to get high reward with less cost? Like in less, with fewer training steps, basically, right? So when it tries to do that, these are all short runs. You can actually see, like, look how short the curves are over here, right? Like some of them are medium length, but mostly they're short curves. So it's trying to figure out how to do it with less compute. And then eventually, if it can't figure out how to do it with less compute, it'll go back to using more compute. I think that's how it works. It's kind of smart, honestly, because, like, these runs are pretty cheap. It can do a lot of them. So I think it's trying to, like, say, okay, if these runs are cheap, I can do a lot of them, and then maybe I find a better set of hyperparams versus investing a whole bunch in these, like, really long runs when maybe I find something that's more efficient. And the really cool thing about carbs is you use the number of seconds that the thing takes as the cost. So, like, it'll just find the settings that get you your policy the fastest instead of being samples or some other bullshit. What the hell chat am I in? Nice when you said a finite number of sweeps. I wake up and like 400 of them are a waste. So have you checked that they're actually doing something? Because there is, I think I showed on stream yesterday, there is a bug where if you look in like all of the results, if they're all like down in the like the low bottom trash, you might just have runs that are failing. They should not actually be failing. This is the Pong sweep, right? Here, let me show you how the Pong sweep worked. Isn't this kind of cool? Right, it found like some decent stuff to start with, and then it found like a different set of distribution of parameters, and then it worked its way back up. Kind of funky. I did some analysis on carbs, so I'm pretty confident that it's good. Have you read this article? I put it in the chat. I gave it a really, really bad, like I gave it a really hard benchmark and carb shredded it. And everything else failed. RL algorithm I'm trying might just be trash. Yeah, so you need your RL algorithm to get some sort of reward. If everything is 0, then there's nothing to optimize. I'll link this one at the same time just for fun, since I see there are a few YouTube people. If you're looking for something funny that's actually kind of legitimate. I don't know, not that many people saw these two articles. Like, everybody saw my really stupid article, but nobody saw the actually kind of fun ones. What the heck is this? What is my... I'm not oh, this is a repost. Show... Damn it. I guess it shows reposts. The end reward is 1E minus 5. Yeah, that's not going to fly. What I suggest with carbs is, like, go find some somewhat sane hyperparameters first, and then let carbs optimize from there. You gotta find, because like if you're not getting reward, like who knows, you might not even have anything that makes sense, right? Like your algorithm might just be straight wrong. This is good for Pong. Let me go back to this talk here. That is the concern, but it is an all or nothing grid world. You gotta find some sort of reward. All or nothing is not good for RL. Right? Is this lava gaps? Wait, this is not lava gaps, is it? From mini grid? That's wild. You look like Wand B CEO, but without the beard. I used to have a beard. Didn't look great. Door key mini grid. You can look at the mini grid settings I have in Puffer. They should give you a decent starting place. Probably, like, if you just tune this with PPO, if you just tune PufferLib PPO, it'll probably work. You could do random search as well, just to seed it to find, like, some random decent hyperparams. It's a decent option. Yes. Walt. This guy? Figure 8. Huh? Why am I under this guy? Wait, why does my profile picture there? That's literally my freaking profile picture. What the hell? L2K? No, that's not him looking like me. That's literally L2K. Oh, because he follows me. I guess that's why it shows up. Wanby is cool. Wanby is cool. That said, give me some credit. I think I am substantially more built. Unless he's a power lifter. uh. The last few months, I've pretty much just been doing... It's been AI running and lifting. That's it. Nothing else. That's all that's going on. You know, reinforcement learn body, reinforcement learn virtual agents. Can't good. Yeah, I mean, I can't believe, like, I think 4 or 5 years ago, I just hadn't done any exercise at all. I don't know what the hell I was doing. Best thing I've done is to, like, invest in getting in shape. That's it. It's a stupid amount of time now. It's like the first 4 hours of my day. But hey, it's worth it. Work from home. Yeah. Yeah, it's rough. You gotta have goals, right? You gotta have goals. Run and lift back to back. Unfortunately, yes, because it saves time. It'd be way better if I split them up, but it saves time. This is an off week for running. These 2 weeks because I'm tapering for a marathon. But last week was a 10K every day, 5 days. 5 days, and then on Sunday 22 miles, and then the whole 5 days of the week was also heavy powerlifting, upper body only. Deadlifts and squats really don't mix with running, though I do miss being able to train that more. But the dumb cardio is important, unfortunately. I don't know. Gonna probably hit some running goals and then back off of it a little bit and see if I do. Maybe get my deadlift back. I don't like this section. What other software do you like using? I run a very, very minimal stack for my work. The whole dev flow is everything is containerized inside of PufferTank. PufferTank runs locally or on the Puffer boxes or on any of my machines. It's got my NeoVim on it, so then I just dev directly in on whatever machine without having to configure anything. Stuff I like. I use Wandby for analysis. Let's see. I really like Raylib for graphics. Raylib is awesome. Reinforcement learning. PufferLib is based on the PufferLib implementation. Its PPO first party is based on CleanRLs. It's just adapted from CleanRLs. CleanRL is really good. What other general stuff do I use? I really don't use very much. Oh, Cython. Cython lately has been the big thing. I love Cython. Run morning and lift at night so I can still do legs pretty hard. All right, you're nuts. I don't know how you run and do squats or deadlifts. It's just like the next day you're just dying. I don't know what your weekly running volume is though. I've had the last 2 weeks were 53 miles apiece. Twenty-five, 30. Yeah, at 25, 30, I think I could still lift. The 50 is just like, I don't even feel good running. It's just, you're just constantly beat to hell. And the other thing is it's even worse this summer because I'm running exclusively around the dish. So my 10K is also 700 feet elevation gain. That's the really rough thing. I'm not fast though, it's slow. But still, it weighs on you. It's basically just try to complete the mileage and not get injured. It's the goal. I definitely want to do a marathon around the dish. That's going to be soon. We'll see about a 50K. I don't think I want to do a longer distance than a 50K for now, though. 50 mile is like way too much training. And way too much, like, you have to do so much right for a 50 mile to not get injured as well. I don't know if I'm willing to do that. $50K I could do. I know, I'll probably shift around as I get bored on stuff. Maybe, I'll start going for like a faster half marathon time after I hit those. That would give me less volume. Probably lift a little bit more. Because basically at the moment I'm just doing bench and overhead press. I'm just trying to get those two lifts to be nice and heavy. Goal is, 1.5 body weight bench and body weight overhead, which I guess would be like 275, 280-ish bench and 180 overhead. Getting pretty close. I'm only like 20 pounds off of them. $650. I want to fix like one more thing on this for the evening before I hop off. I don't think that this is a good point the way I'm making it at the moment. It's not the best way I could be making it. Okay, I think I know how I can make this. What I want to convey is there's this like nearly neurotic obsession over sample efficiency in reinforcement learning to the point that academics would take a look at these two, if these two were different algorithms or different, papers, and this one is really, really fast, but 20% less sample efficient, but it trains 10 times faster. They'll take this, they will say that this is bad, and this one that takes 20% more samples but 10 times longer to train is better. I think that's the way to convey how ridiculous this is. The first one, yeah, obviously the first one is better, right? Unless you're doing like super constrained robotics. But like, this is the problem with academia, right? Is that academics will look at these two and they'll take the second one. This one will be a spotlight paper and this one will be rejected. Yes, you're right. It should be like this. Good. Like this. So they'll look at these two, right? And this one is, it takes a little bit more, a few more samples, but it's really fast. And then they'll look at this one, right? That takes a few less samples, but it's really slow. The thing that's difficult for me to convey is how all these things weave together to create this like perfect tapestry of bullshit, which is plaguing the field. Because there's this next section, and I'm going to have to figure out how to do this in the talk better, because there's this next section where I show that essentially, like, the reason that all the science in RL is wrong. And the reason that all the science in RL is wrong is because the experiments take so long that we can't run enough of them. And one of the reasons the experiments take so long is because of this, is that we select for experiments that take forever. I guess the question is, if we have algorithms that learn optimal policies with infinite samples, then what is there to do in that regime versus the constrained sample? Because it's not infinite samples. Well, I guess that's not the way I look at it. So there's this paper. There have been a couple papers now that show that for a fixed amount of compute that you're going to spend training a model, right? If you're training a language model, you're going to have a way bigger network, so you're going to use way less data, right? Because that compute can only go through so many samples because it's a really big model. In reinforcement learning, you end up with way smaller models that go through way more data. That is the optimal regime for reinforcement learning. So if we want to be efficient with our compute, efficient with our resources, then we should optimize for using a ton of data. That's the argument. Like, you're essentially just slowing everything down by insisting that we excessively optimize for sample efficiency. And mind you, if we have an algorithm that instantly learns from tons of samples, then we're set. You still have to run the algorithm. So let me give you a little back of the envelope here. This is kind of cool. So I've got this MOBA, right? This MOBA is, I think, 1 million-ish steps per second. Let's say 1 million steps per second. This is going to blow your mind. So 16 cores is 16 million steps per second. Let's say we have good enough vectorization to do that, because we kind of do. Okay? Times 60 seconds per minute, times 60 minutes per hour, times 24 hours per day. This is the number of samples per day. We're going to divide this by 1e9. This is 1,300 billion steps per second. Let's say that the observation size is about a kilobyte, which it is. Okay. 1e9 is billion, so that's gigabytes. Let's do 1e12, terabytes. So we're producing 1.3 petabytes of data, simulated data per day on one desktop. So you're not advocating for algorithmic advancement, but instead using existing algorithms to learn cool policies by providing them with the necessary data. That's not exactly what I'm saying. I'm saying that we're using our reinforcement learning in a very bad data regime right now. So what I'm saying is we're throwing away most of our compute. If you're not using your compute efficiently, then you're not making progress, right? If we were throwing away effectively 95% of our compute, then we wouldn't have GPT for another 10 years, because you simply need a certain amount of compute to produce that result, right? So I'm saying that we should not be optimizing for very slow simulators. We should be optimizing for fast simulators, because for reinforcement learning, that's where we can more optimally allocate our compute. And that's what allows us to do things like run 500 experiment long hyperparameter sweeps overnight on one GPU in order to get comprehensive evaluation of our algorithms. And if we want to advance algorithms, we can get comprehensive evaluation of every new thing that we propose. So this essentially allows us to do good science, because almost every reinforcement learning paper out there is wrong at the moment, and provably wrong, because they do not have the compute to run enough experiments on their slow environments. That was like 3 ideas jumbled into one, but hopefully that's mostly clear. Why is the focus on sample efficiency a problem then? Because it comes at the cost of making our algorithm slower and slower in wall clock time. So if you make your algorithm 10 times slower in wall clock time, and that's now the baseline to beat, right? That means you get to run 10 times fewer experiments, and the environments are already so slow that you cannot run enough experiments to be statistically significant. So basically, the vast majority of RL research is just a shot in the dark, because the results that are published are so noisy that they cannot be used to conclude everything. They cannot be used to conclude anything. This is why we have like 100 plus published new reinforcement learning algorithms, and nothing has displaced PPO. Because when you actually use it, on, you know, a non-canned problem that you've actually, you know, done correct comparisons on, PPO kind of just wins. Another way of looking at this is that if we increase our compute efficiency, right, this allows us to do better science on fast environments, which is not the same as simple environments, right? We can make hard, complex environments. We can make them fast. So this allows us to do more research better with any amount of compute resources and to draw more generalizable insights that we can then apply to other problems where we don't have that luxury. Isn't fast environments beneficial? Yes, exactly. Fast environments is beneficial to everything. But the thing is, if your environment is fast and you have an algorithm, like, the problem is that the sample efficient algorithms are trading off compute. Okay, it's not that it's bad to learn fast. It's that they're trading off wall clock time, right? So usually what they're doing is they're trying to reuse the same sample 100 times rather than just getting 100 times fresh samples because they're free. And like having more data is always better than having less data. So you're always going to learn faster if you have 100 times more fresh samples than 100 times stale samples. So making better algorithms to learn from stale data is actually making it harder to push the research forward because of how much longer it takes to train anything, and therefore how much longer it takes to conclude anything because of the number of experiments you need to run to attain statistical significance. Here's another case for you. So this is a paper. I'm the senior author on this one, right? We burned 10,800 hours doing 3 Atari seeds for 5 very, very simple ablations because Atari is actually that slow and because the default setting that RL has converged on in the name of sample efficiency is actually this slow. With the current approach that I have now, right, I could do this same sort of a thing in probably between 5 and 700 A100 hours. The same exact thing. Basically, they're not maximizing GPU throughput because they're doing intermediate computation instead of continuous interaction with the environment. Well, sometimes they are maximizing GPU throughput, but they're doing like really useless work, right? So like the baseline in reinforcement learning, well, actually, sometimes they're not doing either, to be fair. Sometimes the status quo, the default, is that your GPU sits at 5% utilization, right? Because you only run like a very small number of environments and you use really, really small batches. So your GPU sits at 5% utilization, and then you train, and then like, you know, your thing will train in 2 hours, it'll train in like an hour or 2 hours on like 2 to 3 million steps instead of in 5 minutes on like 10 million steps. Where's the puffer thing? Okay, so this Pong sweep right here, each of these runs is like between 5 and 12 minutes, I think. 5 and 12 minutes. If I were to do this with the classic Atari settings that people use, then this would be like 2 to 3 hours per run. Actually, more. Isn't this because of the need for on-policy data? No, this is on policy. What I'm doing is on policy. Because mini-matching technically isn't computing true policy gradient. Okay, that's a fair objection. Yeah, that's a fair objection, but that's still... Nobody makes that distinction. That's still considered on policy. Mini batching is still considered on policy. It's when you're storing archives after an update, like if you're doing Rainbow or DQN, right, where you have a replay buffer, that's considered off policy. You are technically correct that mini batching introduces some off policiness. I actually found that out. I was the one that found this recently. That the PPO paper, the actual paper itself, does not contain mini batching in the same way. It does. It doesn't show. The paper shows gradient accumulation. So actually, it would be fully on policy because it would accumulate gradients over mini batches. That was the implication, but none of the implementations do this. So technically, there's a discrepancy in the biggest paper in the field. That's pretty crazy. I'm assuming gradient accumulation is much worse. Not necessarily. It depends on the environment because it's just doing what? Not necessarily. There's Have you seen the OpenAI blog / paper how AI training scales? Harder environments inherently require bigger mini batches. Because the gradient noise, the gradient noise increases, right? You need more samples in harder environments in order to make accurate updates. There's a critical batch size for every environment, and not just for every environment, for every point in an environment. So any quality policy. It's based on the local difficulty of the problem. It's pretty cool. There you go. It used to be a way better blog post. There used to be like this interactive thing where you could slide a bar around and see like the optimal frontier. It might be in Wayback Machine or something, but it's still good. And there's a paper linked in here, I think. Why they keep redoing their website and being weird with it? There's literally a new paper that says small batches are better. Link it, I don't believe it. Link it. I bet I find that it's wrong in 5 minutes. It'll be the last thing I do. I'm going to check that paper, I'll relaunch the experiment, and then I'll call it for the day. But I do not believe that. Because the thing is, I run hyperparameter sweeps, right? Where you auto-tune the batch size and the mini batch size and everything. And consistently I get, for larger scale environments, I consistently get optimal hyperparameters at bigger batch and mini batch sizes. It's also impossible that small batches are better in wall clock time because they do not make good utilization of GPU. Do you have the link? What's the name of the paper? I'll Google it. You can paste the name. I don't know. I like Big Batch and I cannot lie. Oh my gosh. Do you see this guy? You see this guy right here? I've reviewed 2 bullshit papers by this guy today. I know he's very well known. I've reviewed 2 bullshit papers by this guy today. Castro's usually cool. Well, that's not true. Batch size 8. Well, first of all, this is a dumb sample efficiency claim right here because this is 4 times slower. At small batch size, performance gain is linear. So this is literally 4 times slower. So if we were to stretch this graph out by a factor of 4, right, then this should be here. This should be way over here. And then this should be like way up there because you get so much more training. Actually, we know exactly right here. We take this point because it takes 4 times longer. So we take this point versus this point. This point is better. Off-policy experiments on Atari only. Standard agents. Okay, well, if they're saying that this thing doesn't solve the environment, that this thing completely plateaus, then this is a bad baseline to begin with. Figure 2, we can observe This was your fault because of the paper that you wrote. This is not true. This is not true. You have a bad algorithm implementation. This is not possible. Smaller, but this is simply not true. You're using one of these janky DeepMind libraries that it's like has a wonky implementation. It should be strictly 4 times faster. I do not trust this one bit. I've reviewed 2 bad papers by this guy today. Not counting this one. Yeah, this is wrong. This is like not technically possible. This got into NeurIPS. He got a spotlight. Like, this is the thing. This is the exact thing wrong with the fucking, the RL ecosystem. Let me show you. So, I just found this today. This is, like, one of the most widely cited papers in the area. So, here's one. This is the Mikado paper where he introduces best practices for Atari. He introduces this wrapper that becomes widely used. Where is it? He's a very famous researcher, but like I honestly like I'm getting really bad vibes from some of this work. So here is this wrapper, which has a 25% chance of essentially holding down your keyboard key when you try to take a different action. So 25% of chance of your controller button just getting stuck. And he says that this does not impact learning of reasonable algorithms. This only impacts algorithms that are attempting to exploit determinism. So you should use this to better track evaluation. Now, anybody who's ever played a game in their life goes, it seems like there are a lot of games where having my controller stuck would make it really hard to do precise inputs and would eventually get me killed. Oh, that's interesting. They only include results for Sequest and Space Invaders. What happens if I scroll down to their appendix? Oh, look, they completely fail to solve Breakout and Pong, which are 2 of the most consistent tasks out there, where the original DQN does like more than twice as good, does like way better on both of these. DQN original perfectly solves Pong and gets double the score on Breakout. So, yeah, here's like an incredibly damaging, like, I think this was a spotlight paper, was it? No, it was the other one that was a spotlight paper. Okay, here's the other one. Sticky keys is super common. I thought it was to prevent superhuman control. Nope, it was apparently to prevent exploiting determinism. And I'm going to run, this is the experiment I'm running right after this, is I'm going to use his setting and see if you can even solve Pong with it. Because I think that this is bullshit. And I mean, this is the exact type of thing where like academia will go, oh, look, this looks like a good way to do the generalization, and then it ends up screwing stuff over. The other one is, let me find it. This is the other one. So this is like an incredibly well cited and respected paper, right? It's technically correct. This one isn't even wrong. So this one, he argues that basically all of RL is wrong, like all the scientific results is wrong, except the ones that are done by Google, because researchers are not running enough experiments to obtain statistical significance. I use that you can use the library is fine. But here's the thing, like, think about what this paper is saying. This paper is saying that RL is wrong because you don't run enough experiments. Well, why don't you run enough experiments? You don't run enough experiments because you're optimizing for sample efficiency and making everything really slow in wall clock time, and researchers don't have enough compute resources to run these bloody experiments. So if you wanted to fix this problem, the way to do it is to not release this library. Like, this is not the way to fix the problem. The way to fix this problem is to make the bloody environments faster. And then you don't have a problem, because you can run 100 seeds, which is exactly what I just did with Pong. I can run 100 seeds. I can run 200 seeds in a day, right? For 10, 20 million, whatever I want. So there you go. So this is literally like Google researcher says that only Google research is correct because we made the stupid environments too hard to learn, right? Because they're too slow. So this was dumb. This paper is like heralded as like the holy grail of like what's wrong with reinforcement learning. And this is like an entirely obvious observation that completely misses the point. Are you running seeds sequentially? I'm not running seeds at the moment. I'm running hyperparameters. You can equally as well run seeds though. The point is that the environments are slow, right? That's the reason for this. The reason is that it's not that RL researchers don't know that they should run more seeds. It's that the code's bloody slow. And now here you're telling me that they have a paper in which they're saying that 8 batch size is good. Which is like the worst possible thing you can do from a hardware perspective. In fact, where's their wall clock time? Report wall clock time. Let me see. 40 hours? How many frames is this? Human normalized scores. End step. What is this? What is this plot running? I want to see what it's doing. Over 20 games? I don't know what this plot is showing. He didn't make clear what experiments this is running. Is there an appendix? Did he not even retune the hyperparameters? Oh, geez. Whatever this is, you see that this is a 40-hour Atari experiment. So I don't think he's running billions of frames. Because I could be running billions of frames in this amount of time. Crazy paper. Yeah. This is nutty. They mention as well that they only tuned the not only is this like impossible from a hardware perspective, I think that they only tuned the learning rate. Yeah, it looks like they only retuned the learning rate. Smaller the learning rate, the larger the batch size needs to be. No, that's wrong. You have it backwards. Your implementation is not dividing. Your implementation is doing a sum instead of a mean or something. That's simply not true. Crazy. Well, ridiculous. Mean occurs over many batches. It should be dividing by samples such that your learning rate is per sample. Um, because otherwise you couple your learning rate to mini batch. This is insane. Like, this is just completely insane. Like, I don't know if they found some weird thing where, like, for this specific algorithm, if you don't retune hyperparameters or whatever, it does better in terms of sample efficiency. Like, maybe they found a niche weird thing, but I can tell you right now that this result, where is it? This result is just wrong. It will be straight up, it will be straight up 4 times faster with batch size 32 than batch size 8, and it will probably be 8 times faster with batch size 64. The optimal batch size is so much larger than this, it's not even funny. Like, nobody even uses batch size as small as 64. Like, 512 minimum. It's craziness. All right. I'm going to. I don't know what's up with this. I didn't set out today to go shit on Mark Belmare. Like, I opened 3 papers that all had substantial problems, and they all happen to be, I know Pablo's good, isn't he? I mean, they're probably advisors at this point, right? Still, though, you should know that there's no way it's faster in wall clock time. I don't know. They're probably, so senior advisors now, they probably don't even read the papers. I hope I'm not shitting on like some junior researcher student, um, which is probably the case. But the thing that weirds me out is that like this stupid Mikado paper. This paper is not wrong. This is just like missing the point. So whatever. I this paper ended up doing a lot of damage, I think, just because like it's the wrong message. Um, but whatever. The one that was really pissed me off was the Mikado paper because that one actually it looks like has done some damage. I'm gonna run it now, and if by tomorrow, if I wake up and I have like a conclusive sweep where like, hey, yeah, you can't solve Pong with this stupid wrapper, then yeah, I'm gonna make a cool post about it, and like, hey, maybe we just remove this shit. Atari becomes deterministic again. Nobody cares, and we continue to move on. That is insane. Okay, it's this one. So we run this with repeat action prob 0. We take this out so it does not sweep over this parameter. That's crazy, though. We found some good stuff today. I genuinely hate the amount of time that I end up spending shitting on other people's work. But, like, this field is frickin' cursed. It's cursed for a reason. I'd be way happier if I were, like, reviewing all the awesome things that were coming out every day fixing RL. But it's been 10 years and ain't nothing happened. They're, like, single-digit number of people that have released, like, really, really good stuff that's really pushed the field forward. And then they're, like, a lot of papers that have been nothing burgers at best. And at worst, like, actively misleading to the field. We'll see whether this turns out to be one of them. We'll see. This should give me conclusive evidence either way, right? If I run a really aggressive hyperparameter sweep and it learns to set the repeat action probability down, and then it solves Pong, cool. And then I run a really aggressive hyperparameter sweep with a known good implementation, with a known good search algorithm, right? And it doesn't solve it, or it has a way harder time solving it, right? Then that would mean that this parameter is the problem. We will see. We will see. Okay. Well, that was a roller coaster of a day. I am... A couple last things here, folks. I see for some reason there are a lot of people on YouTube. Like whenever I just start ranting about stuff, I guess the viewership goes up, so I guess it's good entertainment. Let me see. So, if you want to support this work, if you want to support the mission to make reinforcement learning sane again, I guess it never was sane, so just make it sane. Best way to do that is to just help me out, star the repository. It's all I ask. It's all open source work. All these new environments that are in /dev are getting merged into 1.1 relatively soon in a big simulation update. All this hyperparameter search is all open source. It's going to be great. If you want to contribute, discord.gg/puffer. You're free to chat in there. Find something to do around the project. New environment, new feature, whatever it's going to be, testing, experiments, whatever you're good with. We do list contributors on the main page, as long as it's, a substantial contribution, not just like a typo fix. I post all this stuff on Twitter. It's exclusively for, well, almost exclusively for research. I post some articles as well there. And that's about it. I probably won't be streaming tomorrow much, if at all. I'm going to do like some co-working on a different environment that is not announced yet, but there's some, some more stuff coming to Puffer. So probably won't be streaming tomorrow, or only will be streaming like in the morning or later in the evening, something like that. I will be, if I am streaming, it'll be to go over the Pong results, maybe to write that crazy thread if this ends up being actually the case that the Mikado wrappers are bad. Checking on the MOBA results, and maybe making a little bit more progress on the talk. That's all. Thanks, folks. Have a nice evening, and catch you around. Thanks for dropping by.